Welcome to Game Design and Development 3. I'm Brian Wynn, the lead instructor of this course. I'm a professor of games and interactive media at Michigan State University in the Department of Media and Information. I'm also an indie game and serious game developer. In this video, I'll set the stage for what we're doing in this course. This is the third course in the Game Design and Development specialization. I will assume that you have the knowledge from the first two courses. If for some reason you did not take these courses yet, I do recommend that you go back and take them before proceeding with this course. Once again, I'll teach both theory and practice in this course. A lot of the theory comes out in the conceptual video lectures. A lot of the practice comes out through the hands-on technical tutorials that you'll do and the projects that you'll make. One of the best ways to make games is by doing it. To that point, we'll create a 3D shooter game across this course and as a means of putting theory into practice and gaining additional experience with developing games in Unity. And across the course, we'll also discuss game asset creation and concepts, level design, game balancing, prototyping, and playtesting. As I mentioned in the previous course, in addition to my learning materials, I also have included links to several YouTube videos to provide other perspectives, knowledge, and interest. Most notably, I've included several by Mark Brown from his Game Maker's Toolkit series, as well as a few from the Extra Credit series and some recorded talks from the Game Developers Conference. I encourage you to watch these videos to add breadth and depth to my materials. Are you ready to level up your game design and development skills? In the next set of videos, we'll get started on the 3D shooter project. The hands-on tutorial is presented right away, but feel free to pace yourself on the development of the game across the entire course and intermix development with my other video lectures and materials. After all, the concepts, theory, and practice of making games goes hand in hand. Let's begin. In this project, you'll continue to learn about game development in Unity. This time, we'll be creating our first 3D game in the form of a first-person shooter. First-person shooters are a type of shooter game featuring a first-person point of view, in which the player sees the action through the eyes of the player character. They differ from third-person shooters in that in a third-person shooter, the player can see the character they're controlling. Gameplay primarily centers around movement and shooting, but other typical mechanics include a combination of exploration, resource collection, and puzzle solving. Many people point to id Software as being one of the most influential companies on the first-person shooter genre, starting with their 1992 release of Wolfenstein 3D, which was quickly followed by the much more popular 1993 release of Doom. Quake, which was released in 1996, was their first true real-time rendered 3D polygon-based game. These three games have spawned many sequels, clones, and really inspired both game players and game developers alike. But there are many first-person shooter games that further define the genre across the 1990s and 2000s. Here are just a few of the notable IPs. The fact is that for more than the last 25 years, first-person and third-person shooters have made up a substantial portion of the game industry, particularly in the AAA space, driving not only game sales, but also game hardware sales to support the ever-advancing graphics rendering that these games demand. But there have also been several non-AAA first-person shooter successes, which typically push novel gameplay over AAA graphic quality, like the 2007 hugely popular first-person puzzle platformer Portal, which was born out of a student game project that evolved into this popular franchise, and the 2016 breakout indie game success Superhot. In this project, you'll get your chance to create your own first-person shooter game. The concepts we will learn includes creating 3D games in Unity. We were introduced to 3D in Unity back in the Solar System project, but this is the first actual 3D game. We'll also use the ProBuilder package to help in grayboxing our levels, that is, level design prototyping. Through the use of ProBuilder, we'll discuss some 3D modeling concepts, such as vertices, edges, faces, extruding, and edge loops. We'll also practice a typical level design pipeline from grayboxing to an art pass. We'll further explore the asset pipeline. In particular, we'll talk about getting 3D assets into your game and setting them up. And we'll get quite a bit of experience with doing level design in 3D space. Other concepts include, we'll learn to create a particle effect in Unity. We'll learn how to set up a NavMesh to have enemy characters that move intelligently through 3D space. We'll explore the Unity audio mixer for mixing together different groups of sounds. We will re-emphasize good coding practices such as creating and following a coding standard. We'll discuss ad hoc programming versus generalized programming, all while being exposed to more complex game systems that we have been building across the last several projects. And as we've done on all the previous projects, we will continue to get familiar with the Unity editor, continue to learn Unity best practices, and continue to learn Unity tips and techniques that hopefully you can apply to your future game projects. Once again, in this project, we'll be using the tutorial format where there's a sequence of tutorial videos that you can watch, replicate, and learn from. During the lessons, do what works best for you. There are a lot of little specific details across this project. You may need to rewatch some of the videos multiple times to make sure you're reproducing things exactly, as well as understand all the lessons being taught. As I've mentioned before, we'll be covering many concepts and practical skills as we go. Try not to just replicate what you see, but really try to understand what you are doing and why. The goal as you work across the project is to build your knowledge so that once you're done with all of the projects, you're capable of creating your own project without a tutorial, or at least being part of a team that does this. As always, read the assignment. You will need to use both the videos and the assignment write-ups to complete the project. I'm always surprised how many learners make mistakes because they simply do not follow the instructions. In the following videos, we'll run through the tutorial portion of the project, and you'll begin making your game. While making games is sometimes challenging, remember, you're making games, so make sure you're having fun. Take the time to play and experiment with ideas, explore the Unity documentation, get inspiration from other games, and discuss ideas with your fellow students along the way. Let's begin. In this video, we'll create our 3D Universal Rendering Pipeline project. But first, let's talk a bit about rendering pipelines. The rendering pipeline is the steps the game engine goes through to draw or render the scene. Different rendering techniques can create higher quality or lower quality graphics and may be more optimized or less optimized depending on the graphics hardware of the computer. Unity provides support for 3 different rendering pipelines, including the built-in rendering pipeline, the universal rendering pipeline, and the high-definition rendering pipeline. The built-in rendering pipeline is what we used in the Solar System, 2D Shooter, and 2D Platformer projects. It is Unity's original rendering pipeline. It works well on a variety of hardware, but it's not very customizable and does not support some of the modern rendering techniques. The Universal Rendering Pipeline, or URP, is a lightweight rendering pipeline that provides high-quality graphics across a range of hardware, from mobile devices to high-end PCs, while maintaining optimal performance. It has become the most popular rendering pipeline for games in Unity. For this project, we'll be using the Universal Rendering Pipeline. The High Definition Rendering Pipeline, or HDRP, is a heavyweight rendering pipeline that takes advantage of the latest high-end graphical rendering techniques, but only supports high-end hardware, such as found on modern gaming PCs or game consoles. Both URP and HDRP are scriptable rendering pipelines, which means they're both highly customizable via C# scripts. You can, in fact, write your own custom rendering pipeline using SRP. Let's get started. First, let's open up Unity Hub, then select Projects on the left-hand side and the New Project button. At the top of the window, we select the version of Unity that we're using for the class. Now you make the choice of the rendering pipeline you'll be using based on the project template that you choose here. As we said, we're using Unity's Universal Rendering Pipeline for this project, so we want to select 3D URP as the template for our project. Now you may need to scroll down a bit to find that option right here, 3D URP Core. Let me select that. And notice that the template is not yet downloaded, so we have to start by downloading the template. Let me click that button now. And once downloaded, just like before, we can specify the name of the project. I'm going to name this 3D FPS. We pick the location where we want to store it. Once again, I've got a Unity projects folder within my user account. It's outside of any cloud syncing folder. And they added a couple new options here to Unity Hub where you have to specify what Unity dashboard organization you want this to belong to. I'm just going to go ahead and select my Unity account. And you can also connect it into your Unity dashboard and connect it to Unity version control if you wanted to. I'm going to go ahead and turn these off and skip that step for purposes of example. But of course, you could do this if you wanted to. And I'll go ahead and click Create Project. Unity will now create a new empty 3D URP project for us, which could take some time. Once your project has been created, it should open in Unity. In my previous projects, we set up the favorite layout. If your editor doesn't look like mine and you want it to, you should choose the favorite saved layout in the layout dropdown here. And of course, you can adjust this layout as you go. Let me switch back to the game view and the scene view. If you look in the project panel, notice the Universal Render Pipeline projects come with some assets for showing off its rendering capabilities. We won't be using these in the tutorial, so let's reorganize them into a single folder to get them out of the way, but keep them around in case you ever want to check them out. So let's go ahead and right-click on Assets and create a new folder. And I'm going to name this folder URP Assets. And I want to drag everything in here except for scenes into that folder. So I'll go ahead and use Control-click to select all of these items except for scenes and drag them into the URP Assets folder just to move them out of the way. And now we're ready to start working on our 3D first-person shooter project. We'll be using the new Unity input system once again for this project, like we did for the 2D shooter and 2D platformer projects. So let's get that set up. The first thing that we need to do is import Unity's input system package. To do this, open the Package Manager under Window, Package Manager. Then in the Package Manager on the top left, switch from Packages in the Project to Packages in the Unity Registry. And these are all the packages that Unity provides. Once again, you can scroll down to find the package that you want. They're alphabetical. We'll find the input system here and go ahead and click Install. Once you hit install, you should get a pop-up warning about switching to the new input system. We want to do this, so go ahead and select Yes here to enable the backends. After clicking Yes, your Unity editor will restart, which could take some time. Okay, we have the input system installed. If you look at the packages in your project, you should now see input system here. Let's go ahead and close the package manager for now. Then if you go under Edit, Project Settings, and then select Input System Package, here you can see a text box telling us settings for the new input system are stored in an asset. If we were making an entirely new project from scratch, we would need to click the button here and set up the input package asset. However, we do not need to make this asset for this project, as we'll be importing a custom asset package in the next step that includes an input system settings asset already set up. For now, we have our input system package. We've provided you with a custom asset package to help you build your project. In fact, we provided everything you need for the tutorial portion of this assignment. Later on, you can add your own assets in the modifications part of the assignment. Download the asset package from the link we provided in the assignment. Once the package has been downloaded, make sure you know where it's located on your machine, most likely in your system's default downloads folder. The file we provided to you is a zip file, so we need to extract the contents before we can use it. If you're on Windows, you can right-click on the file and choose Extract All. And then pick the location where you want to extract it. I'll just put it in the Downloads folder and extract. If you're on a Mac, you can extract the files by double-clicking the zip file if it did not auto-extract for you when you downloaded it. For the next step, you need to make sure your project's open in Unity, and then go to the Assets menu and choose Import Package, Custom Package, and we need to navigate to that extracted zip file. So in Downloads, I can go into the 3D FPS Assets folder and go into the additional subfolder and then find the Unity package file and go ahead and open it. This will bring up a checklist of all the assets and folders found within the provided package. By default, everything should be selected, and go ahead and click Import. Now you can see in the project panel here, we have several new folders here which contain wonderful assets that we're going to use to build our project. Now before proceeding, I will rename my scenes folder, as I've done before, as _scenes, just so alphabetically it's sorted to the top of the list, makes it easier to always find my scenes. In this video, we'll import ProBuilder. ProBuilder is a 3D level design tool now owned by Unity. It adds tools to build, edit, and texture custom 3D geometry right inside Unity, so you don't need to go to an external 3D tool such as Blender or Maya, at least for basic level design. We can import the ProBuilder package into our project, much like we imported the input system. From the drop-down menu at the top of the Unity editor, select Window, Package Manager, to open the Package Manager window. In the top left of the Package Manager window, select Packages and Unity Registry. In the search bar, let's search for ProBuilder. And there it is. And I'll go ahead and select Install. And this installed the ProBuilder package into our project. With ProBuilder still selected in the Package Manager, on the right-hand side, you should see several tabs here. Go ahead and click on the Samples tab. This contains additional sample assets that we can bring into our project. Click on Import next to the Universal Rendering Pipeline support, since our project is using the Universal Render Pipeline. Notice there is also a high-definition render pipeline support file as well, which we would want if we're using HDRP. We're not for this project though. Go ahead and close the Package Manager. If you look in the project, you can see the Samples folder now, which was imported. Within the folder is a material called ProBuilder Default URP. We want to set this as our default material for ProBuilder, since it works better with URP. To do this, we need to make a change in the Unity preferences or settings. On Windows, select Edit and go down to Preferences. On the Mac, select the Unity menu and choose Settings to get the same result. In the resulting window, select ProBuilder, which is a new option in here since we installed the ProBuilder package. If you scroll down, you should find an option for Mesh Settings and find the Material option underneath it. It should currently be set to None. And we want to set that to the ProBuilder Default URP. So rearrange your windows so you can see both your project tab and the settings window, and go ahead and drag the material into that spot. So it's set to ProBuilder Default URP. Now let's go ahead and close the preference or settings window. And congrats, we are now ready to use ProBuilder. We'll use it extensively across the first set of videos in this project. With all of our setup out of the way, we can now start learning how to use ProBuilder within Unity. Within ProBuilder, we'll create and manipulate 3D shapes. As you may have learned in geometry, 3D shapes have vertices, edges, and faces. Vertices are the points where two or more edges meet, such as the corners of this cube. Edges are the line segments that join two vertices together. Faces are the flat surface of the 3D shape, framed by edges. For example, this cube would have 8 vertices, 12 edges, and 6 faces. When you create a shape in ProBuilder, such as a cube, you can manipulate it as an overall object, or you can select its individual vertices, edges, and faces, and then use the manipulation tools such as move, rotation, and scale to modify the 3D shape. Let's jump into Unity and see this in action. To use ProBuilder, we need to bring up the ProBuilder window. We can do this by going to Tools, and then selecting ProBuilder and ProBuilder Window. This will bring up the ProBuilder window. We can then grab the tab here and dock it. I'm going to dock it next to the Project tab, so I can switch back and forth between the Project and the ProBuilder window. Notice there's a lot of options here, each with its own color code. Each color means something different. Brown is used for tools. These are tools that open in a separate window or scene view overlay when you use them. Blue is for selection tools. These set and change the selection of objects you're editing with ProBuilder. Green represents object tools, which are mesh editing tools that affect an entire object. And red is for geometry tools, which allow you to edit specific parts of a mesh. If you prefer, you can use icons rather than text. If you right-click in the empty area of the ProBuilder tab, you could then select Use Icon Mode, which may be more visually appealing. This changes all the options into symbols, but it keeps the color coding. I'll use icon mode, but feel free to toggle back and forth as you see fit. Once again, you can right-click in the open area, switch to text mode, right-click, switch to icon mode. If you ever need more detail on what an option in the ProBuilder menu does, you can just hover your mouse over that option and wait for a window to pop up. This will give you the name of the option, the hotkey to use it, and a description of what it does. One nice thing the ProBuilder menu does is it grays out options that you can't use on your current selected object. Let's start by creating a new shape by clicking the New Shape tool. This brings up the Create Shape panel within our scene view, and I'm going to initially select the cube shape. Next, within this panel, you can actually open the shape properties, and my screen is kind of small, yours is probably bigger, but I can actually drag this up so I can see those shape properties. And within these shape properties, you should see several options here. The shape allows you to pick the shape that you're going to make, much like the icons at the top of the Create Shape panel. We'll keep it as a cube for now. The pivot option defines the location on your object that your object will rotate around. We want this in general set to center, so I'm going to change this to center. And the size option allows you to make your object a specific size on each axis. These will update dynamically as we draw our shapes out in the scene, or we can set them manually. So let's go ahead and create a cube out in our scene. We can do this by left clicking and dragging. And notice it's dragging one side of our cube out. And when I let go, I can then move my mouse up to create the other side. And then when I click, it will set that cube in place. And you can see as I was doing that, it was updating the X, Y, and Z size properties here. Now this cube is different than a standard Unity cube as it's designed to be used by ProBuilder. It has a different kind of mesh and mesh collider on it. Plus it has the ProBuilder mesh filter script attached. The ProBuilder scripts allow us to edit the object with ProBuilder tools, which allow us to make more interesting and complex shapes. Now back in the Create Shape panel, let's try changing the dimensions of the cube that we just made by changing the X, Y, and Z properties. So for example, let me change the X to 4, the Y to 3, and the Z to 1. And notice the cube is changing as we go. Once you deselect your object, for example, by clicking in the hierarchy or by clicking the Create Shape button again, you'll no longer be able to see the panel to tweak your shape. However, until you modify your shape with ProBuilder tools, you'll be able to still access some of the settings in the inspector. So let me select my cube in the hierarchy, and within the inspector, you can see the ProBuilder shape script, and the shape is set as cube, and the size is set right here. So I can go ahead and change the size dynamically this way as well. And if you click the Edit Shape button, it will actually bring up your overlay over here, and you could change them dynamically here as well. And I'll set it back to 4, 3, 1. Now, if I wanted to make another shape, let me click the New Shape button again, and notice it's got the same settings as before. This time, rather than dragging out, I can actually hold the Shift key, and holding the Shift key, if I just click, it will automatically create a new game object based on the settings that are shown here in the Create Shape panel. Depending on the situation, you may want to draw out the shape within the scene, as we did for the first cube, and other times you might want to preset the dimensions and shift-click the shape into existence, as we did with the second cube. Now, if you look in the scene view, notice there's a new bar at the top middle with 4 options here. These options allow us to select and modify specific parts of a ProBuilder shape. Starting on the far left, we have the Object Selection tool, which is currently selected. This tool allows you to move your entire object in the same way that Unity normally allows you to move it. So with that selected, if I go to the Move tool, I get my normal gizmo here, and I can move things along any of the axes. The next selection tool is Vertex Selection. If I select that, notice I actually see the vertices, and I can click on an individual vertice and move just the vertice. And notice I can do something that I can't do with a normal cube in Unity. I could actually modify the shape of the cube by pulling out a vertice in any of the directions. The next option is the Edge Select tool. If I select that, I could then click on any edge between 2 vertices and then use the same manipulation tools. I can move out the edge itself in any direction. The last tool on the far right is the Face Selection tool. Let me select that, and you can select an individual face and once again move just that face. Okay, and you can see how we could dynamically adjust our object to be a completely different object than it started as. Now, for all of these selection tools, you can hold down Control on Windows to select multiple, or Command on the Mac. And if I pan around here, you can see I can select 3 at once, and then I can move all 3 at the same time. Okay. And let me switch over to Vertex Selection, and notice if I select a vertice and hold down the Control key, I can also select 2 vertices at the same time and move both of those vertices together. Now let's move back to our first cube that we didn't alter. So let me select the first cube, and I'll tap F so I move my camera view to it, and I'll zoom out a little bit so I get a better view on the whole thing. And for the next thing I'm going to demonstrate, we want to use the Face Selection tool. So let's go ahead and select the Face Selection, and I'll select one face here. And notice, based on what you click, your ProBuilder menu will change. So let me click off. Notice all the things that are gray. Then let me select a face again, and all the things that light up. Now that the face is selected, we'll be able to select the Extrude tool, which is near the bottom of the tools available. It looks like this, sort of a blue box with a little gray box inside of it. And it says Extrude Faces. This tool allows you to add extra geometry to your object. Let's just try pressing it. And notice our cube expanded. But it expanded in a special way. It wasn't just pulling the face out. It actually added new vertices and edges in the middle. And if I click it again, you can see that again. Okay, and if I go to Vertex Selection, you can see all the new vertices here and all the new edges between those vertices. So the difference between Extrude and the Move tool is that the Extrude will create new extra faces, edges, and vertices, while Move simply extends the already existing geometry. With the extra faces, edges, and vertices that the Extrude tool provides, you can use this tool to create more complex shapes. So for example, let me go back to the Face Selection tool, and let's select this top face here. I'll move my camera a little bit so I can see it a little bit better. And I'll hit Extrude again. Notice that it created a new extrusion here. And now with my Move, I can just pull this up, and I can make essentially an L. Okay, I can grab this face and pull this out. Once again, when I'm pulling, I'm just moving. I'm not adding new vertices and edges, but the first Extrude actually created those vertices and edges that allow me to pull it out. So I took that cube and turned it into an L. Now, a lot of the tools in ProBuilder have additional options. Notice all of these tools that have the little gear means there's additional options here. And if you Alt-click on the tool, it will bring up the options window. And if you're on the Mac, that would be an Option click. So let me hold down Alt and click. This brings up the option window for the extrude tool. And notice one of the options is the distance to extrude. And right now it's set at 0.5. I'm going to change this to be a 1. And once you make the change, that will change the tool. So future times I click on this, it will extrude by a distance of 1 meter rather than half a meter. So let me go ahead and extrude, and you can see it's a bigger extrusion. And I'll go ahead and close the options here. Okay, feel free to play with these basic ProBuilder tools to get the hang of them. We'll begin using them for actual level design in the next set of videos. Now that we've gone over the ProBuilder basics, let's start to prototype our first level. We'll use ProBuilder to graybox or block out our level. Grayboxing is a level design technique where you rapidly prototype the level using basic visuals, such as gray boxes, to get the level into a playable state as quickly as possible. With the Graybox prototype, you can test the level layout and design and iterate on it as needed prior to investing a lot of time in the production of polished art assets. ProBuilder is an excellent tool for grayboxing within Unity, as it allows you to quickly block out levels. But prior to jumping into Unity to lay out a level, even in Graybox form, I strongly recommend starting the design process on pencil and paper. Drawing a top-down map of your level is a great place to start. Here's a top-down map of a simple level design for our tutorial level drawn on grid paper. You can see we have 2 rooms with a door between. One room is where the player starts. It has a platforming challenge to obtain a key that unlocks the door. The second room has another platforming challenge, including a moving platform, to get to the goal of the level. Okay, let's take this simple level design and graybox it within Unity. So far, we've just been playing around in the sample scene. Let's start by creating a new scene for our level 1. Let's switch over to the Project tab, and under Scenes, we can right-click on the Scenes folder and create Scene. And I'm going to label this scene as Level 1, and then go ahead and double-click it to open the scene. Let's start by creating a cube in our level, which will turn into our floor and outer walls. So back in the ProBuilder tab, let's click on New Shape. And here in the Create Shape panel, I will choose the cube. I'll set the pivot as first corner, and I'll set the size to X of 2, Y of 1, and Z of 2. And I want to be precise so we all can follow along. So rather than draw the shape out, I'll preset the size. And then once again, we can hold the Shift key down and just click to create our cube out in the scene. Now remember, you can always adjust the size of a ProBuilder shape once they're created using the ProBuilder shape component over here in the inspector for the respective game object. This cube will become the floor of our level. I always like to build my scene starting in the center of the 3D space, but our cube was just arbitrarily drawn in the world, as you can see based on its position. So let's go ahead and resolve that. Over here in the transform, if you click the ... we can then choose Reset, which will reset all of the properties back to the center of the world, so 0, 0, 0. Now if we move our mouse into the scene view and tap F, we can zoom right to the cube. And if you click the New Shape button again, it will take away the New Shape panel there to get it out of the way. You can see the cube is actually sitting on top of the world grid. You can see the grid down here below. We want this to be the floor, and I would like everything to build up from Y of 0. So since this cube is a height of 1, let's set the game object to be at Y of -1. So the top of the cube will be right at Y of 0. This way, everything we place upon the floor will build up from a Y of 0. So here in the transform, I can just set the Y to -1. And that way you can see the 0 grid here is right across the top of the cube. As we build our level, it's nice to work off the grid when positioning game objects. One way to do this is to turn on grid snapping. First, in the top right corner of your scene view, you can click the drop down for toggle tool handle rotation to change it from local to global. So let's switch it from local to global. This will make sure the tool handle or axis gizmo on the game object is shown relative to the world rather than the object's local coordinate system. But more importantly, when we're in global mode, Unity will let us turn on grid snapping. You can do so by clicking the little icon here with the magnet over the grid. And you can tell it's turned on when it's this blue color rather than the just normal gray color. Now, if we use the move tool and we move in various directions, notice that our object will snap to the grid location. Okay, so rather than just being freeform, it snaps. And if you turn off snapping, once again, we can do freeform placement. Okay, so snapping and non-snapping using that. Okay, let me reset my position back just so we start where we were at 0, and then -1, 0 for the ground. We want to select the face on the right side of the cube, the side with the blue or Z-axis arrow pointing out from it. So let me just rotate around here. Once again, you can hold down your Alt key or Option key with the left mouse to, spin around the view. So I just want to be able to select this face. So once again, let's change from object selection to face selection here, and then select that face. And then let's find the Extrude Faces tool in the ProBuilder menu, which once again is this icon here, the blue rectangle. And I'm going to Alt-click on this to bring up its properties or its settings and make sure the distance is set to 1. I did this in the last video, but if you didn't follow along or if it got reset somehow, make sure that your distance is set to 1. And then we can go ahead and extrude this face once. So there is a button at the bottom of this window. You can tap that to extrude the face. And let me close the options. Or of course you could always just click the button itself. Now that we've extruded the face, we have some extra geometry here, and we can pull this face out without affecting that sort of original geometry. And let me zoom out quite a ways. I'm going to actually pull this out and notice it's snapping as I go. I guess my snapping properties are set to the 0.5 mark. Yours may not be. So if you click the drop down here under the grid snapping option, you can see the setting here. Yours is probably set to 1, which basically everything will snap to the 1 meter mark. Okay, but for a little more precision, you can go ahead and change this to 0.5, and then everything will snap to either the whole number or halfway between. Okay, so I want to drag this out and bring it all the way out to 34 in the Z direction. So you can see that over here in your ProBuilder mesh as you're dragging this out. Okay, and if I zoom out here in the scene view, you can kind of see the whole shape there. Let me kind of recenter my scene. Now we want to select the two faces closest to us on the object on the X-axis or the red arrow. So this face right here, this long one, and then the short one as well. So once again, I can hold down the Control key on Windows or the Command key on the Mac to select multiple. And following the same process, I want to first extrude this face. So I'll click the Extrude Faces button, and we get some new geometry here. And then I want to pull this out until it gets to 34 in the X direction. Okay, so once again, over here in the ProBuilder mesh filter, you can see the X of 34 and the Z of 34. We should now have a nice basis for our floor. The next thing that we'll do is create the outer walls to wall off our level. So let's select the Edge Selection tool right here in the scene view. And we want to select the long edge closest to us. So the edge right here. So let me zoom out a little bit so I can see it. And I want to select this edge right there. So you don't need to select the other little short part, just the long part. Now what we want to do basically is we want to create a border around this entire object. So with this edge selected, I could then come over to ProBuilder and I can select this Insert Edge Loop option. And you can see it says connects all edges in a ring around the object. Okay, so if I click on this, you can see I get a new edge that goes all the way around the object. And with that selected, I could use my move tool and I could just move this edge actually over to the far side, the far right side, and I want to basically parallel what's on the left side. So I'm going to bring it to the point where it's got 2 cubes of space remaining. Okay, and if you ever deselect one of these edges, so let me just click down here, you can click back on it, and if you double click it, it will reselect the entire circle of the edge around the object. We need to add another edge loop to mark off the last wall we want to make. So let's select the long edge on the right side of our object. So right here, let's select this one. And then once again, let's click the Insert Edge Loop tool. This will give us a new edge all the way around the object. And just like before, I'm going to move it, and I'll move it down here to have about 2 square pieces remaining. You might have to reorient your camera so you can really see what you're doing. So I've got 2 squares remaining there. Now we have edge loops all the way around our cube. This gives us the geometry that we can select and modify. So let me zoom out so I can kind of see this from the top. Pan around a little bit. Okay, so we can see all of these edges, and choosing the face selection tool, I can now click these faces, and once again, holding the control key down on Windows or the command key on the Mac, we could then select all of these faces around the outer edge of our object. Now, just like we did before, we've got this base, and we want to extrude up from the faces that I've selected. So I'll choose the extrude tool once again under the ProBuilder menu, and we get some extra geometry. You can see it comes up 1 unit there. And now that we've got that extra geometry, I can then stretch it out. So I'm going to go ahead and move it in the Y direction up, and looking over at your ProBuilder mesh filter option, let's bring it up to a Y of 17. Okay, and now you can see we've got a nice compact space within these outer walls to build our simple level in. You can see how using ProBuilder makes it easy to graybox levels with these tools. Without them, we would have had to make mini cubes, resize them, and put them all together. With ProBuilder, we can get a sort of rough approximation of what a 3D modeler would use in tools like Blender or Maya to help us with grayboxing right here within Unity. Now, while our hierarchy looks clean right now, we should stay ahead of our organization. So let's go ahead and rename our cube. And this is going to be called our level, floor, and walls. Okay, because it represents our floor and outer walls. And I'm going to put all of my Graybox elements within a parent object. So let me go ahead and create an empty game object here in the hierarchy. And I'm going to call this my Grayboxed environment. And once again, when I created the empty object, it just was placed arbitrarily in the world, and everything is going to go under this. So I'm going to reset its transform to be at 0, 0, 0, just so every object will be relative to the origin of the world. And let me drag and drop my level, floor, and walls within the Graybox environment, so it's a child of that. And let's go ahead and save our scene. In this video, we'll continue using ProBuilder to graybox our first level. We'll block out room 1 within the level. Start by making sure your scene view orientation is such that your x-axis is coming at you and the z-axis is pointing to the right, so your view is similar to mine. We're looking down into our cubed space here. Now we want to divide this cube space into 2 rooms separated by a door. So let's go back to our ProBuilder window and select New Shape. And we want to create a door. So select the door option in the shape selector. And let's go ahead and set the size of the door to 4, 4, 1 in the X, Y, and Z. And set your door settings so your pediment height is 1 and your side width is 1. And then let's go ahead and shift click this into existence. So I want to place this about, in the middle of my room here, in the middle of the space. So holding down shift, I'll click. Notice the door was created, but it's facing sideways as placed. I'll rotate this 90 degrees so it's facing my current view. So over here in the inspector, I can just set the rotation along the y-axis to 90. And then let's go ahead and position the door. So let me click the new shape button to get rid of the overlay. And with the move tool selected, I can move it around. It's got snapping going once again. So I want to move it over to this side of the room with about 3 squares left on the right side and, a bunch on the left side. So the door is going to be over to this side of the room, and then I'm going to have a wall around the door. Also make sure that your door is grounded, so the Y should be set to 0. Now to create the wall, we're going to use the edge selection tool and build it off of our current door game object. So let's use edge selection, and I want to select basically all the edges on top of the door. Okay, so we can click one, and then holding down the control, we have to select each of them, and it's kind of hard to see them because of the gizmo that comes up. So you might want to start on your right side actually, and you might need to zoom in a bit. If you press F, you can zoom right into the door. Okay, so I'll select that one, then holding down Control on Windows or Command on the Mac, I can select across the back of the door here, and then do the same thing on the front of the door. So all 6 segments are selected. You have to be a little careful here because if you select the wrong edge, like a lower edge, it's really going to kind of mess you up because it's going to pull everything up. So now what I'm going to do is I'm going to just move this up. So using the gizmo here, I can pull up in the Y direction, and you can see I'm making essentially a wall above the door because there's already the geometry there. It's like it's already extruded. Didn't have to extrude. And I want to bring this up to a Y of 16 should be the right height. Once again, over here in the ProBuilder mesh filter component, you can see the Y of 16 there. Now let's select the edges along the right side of the door. So let me zoom in again and rotate around a bit so I can see these edges. So I'll select this one, and then holding down the Control key on Windows or Command on Mac, select the next one, and then this one and this one. So there should be 4 edges along this side, and I'm going to pull these out. So right where it connects, so it should span across to the wall there. Let's zoom out here and see if our height is right. Looks like the height is right as well. And then we want to do the same thing on the left side. Okay, so once again, we will select all of our edges. There's 4 of them, and then we're going to move them out. And span them all the way across until it gets right to the wall. I think I need to go another half unit there. Okay, so now we've got a door with a wall separating the overall space. Now you can see that my wall is, not really equally divided here. So let me go back to the object selection and then just pull the whole object over. So, it's roughly divided in half. Doesn't have to be exact. Okay. Okay, now we have 2 rooms in our level divided by a door. Let's set up the first room. Within this room, we'll have a little platforming challenge to get a key to open the door. So let's start by rotating our view in the scene so we're looking into the room. So once again, holding down the Alt key or the Option key on Mac, we can rotate our scene view. So we're kind of looking down into the room. And I'll want to place this so I can kind of roughly see each of the corners, maybe not quite the bottom corner. And once again, we're going to create a shape for our platform. So let's open up the new shape tool. And we want to create a cube for this platform. So let's select the cube shape. And I'm going to make this an X of 5, a Y of 2, and a Z of 5. And once again, we can shift click this into place, kind of up toward the top corner here. Let's create that. And let's go ahead and name this cube as our platform 1. And then let's go ahead and close the shape tool and zoom in here. And let's place this shape kind of back in the toward the corner. It doesn't have to be all the way in the corner here. Okay, now let's go ahead and make another platform. So we'll bring up the new shape tool again. We're going to do roughly the same size, but we're going to make this a little bit taller. So rather than a Y of 2, we'll make a Y of 4. So it's twice as high. And once again, let's reposition our view here a little bit and shift click this into place. And once again, we can rename this as platform 2. And then let's close the shape tool and let's position this one. Okay, so I want this to be roughly the same location in terms of the Z and Y, but let's change the X location to move it over here a little bit. So once again, the character will have to come over and jump up on this platform and then jump from this platform to this platform. So we've got our 2 platforms created there. We use the top of platform 2 as the location for the key to the door. Since we're grayboxing our level, we can assume that we do not have anything from our artists or programmers yet. This means we do not have an actual key asset to put in here. However, the key is an important part of the level, so we want some rough approximation of it. So let's use the Create Shape tool here in ProBuilder. And for the key, we can just create a cube once again, but we'll make it a small cube, maybe 1 by 1 by 1. And I can reposition my camera a little bit here in the scene, or my view into the scene. And once again, shift click it right here on top of platform 2 to create that cube. And I'm going to rename the cube as key to door. And then we can, close the shape tool so then we can move this into place, roughly into the center of platform 2. And I can move it up a little bit because maybe it'll be hovering or something like that for the player to pick up. Remember, as you're moving around your game objects, if you want to move the entire game objects, you have to be in object selection mode versus edge, vertex, or face selection mode. Now we could do more to make this object look like a key, but we won't. This is part of the process of grayboxing. Deciding if you should make things stand out or look more representative of what they should be in the game is a balancing act. You can easily lose a lot of time making something look nice or representative that you're just going to replace anyway with the actual art when you have it. Keep in mind how much you need to do to make your level design clear and try not to go overboard. One simple thing that we can do is color the key to door to stand out using Vertex Coloring Tool. So here in the ProBuilder with the key to door selected, let me click on this icon, which looks like a paintbrush in front of a cube. This brings up our Vertex Colors window. You can see it's a color palette here that has a bunch of colors pre-selected, and you could override these or change the colors just by clicking on them. But we'll just use the colors that we have. And I want to apply maybe a green color to this key. So let me just pick one of the green colors and click apply. And you can see it changed from a gray box to a green box. And this is probably enough for our gray box prototype to make the key stand out. Now this room will be the starting location for the player, so let's also indicate that important location as well. So let me close my vertex color for the moment and bring up new shape. And to represent the player, we'll go ahead and select the cylinder shape. And let's set the size of this location as 1. And I know later my player height is going to be 2 meters, so I'm going to set the Y to 2 and 1, so 1, 2, 1. And then let's go ahead and let's zoom out here a little bit and kind of reorient our view. I know the location of the player to start with will be kind of over in this corner. So I will once again shift click to create a cylinder right in this location and then tap F to zoom in. And let's go ahead and rename this as player start position. Since this is an important object as well, let's recolor it, bringing up the Vertex Color tool once again. And let's go ahead and choose maybe a blue color for the starting location of the player. And go ahead and close your Vertex Colors. Okay, the primary elements of this room are set up. Let's clean up our hierarchy a bit. We can select all of the objects that we've created, the door, the platform 1, platform 2, key to door, and player start location, and let's drag and drop them into the Graybox environment so they're all children of the Graybox environment. And let's finish by saving our scene. In this video, we'll finish grayboxing our first level. Our focus will be on blocking out our second room. Within the second room, we'll have another platforming challenge to get to the goal of the level. Let's start by rotating our view in the scene to look into the second room. So right now I'm looking at the player start location. So let me just zoom out quite a bit here, and we'll pan over so we can look into that second room location. And once again, just like the first room, I'll position my camera so I can roughly see, the corners of the room here. Okay, we want to create a pillar in each corner of this room. And to create a pillar, I'm going to make a new shape. So let's click on the new shape button. And I'm going to pick a cylinder as my shape type. And let's set the size of the cylinder to 1, 3, 1. And kind of up toward the upper right-hand corner, I will shift click it into place. And I can always reposition it afterwards. And there I've got a cylinder. And if you tap F to zoom in on that cylinder, you can see the cylinder is made up of kind of 6 triangles that define the shape of the cylinder. And that's one of the cylinder settings. So I can actually increase the number of sides. So let me go from 6 to 12. So you can see we've got 12 triangles now, and it makes a much smoother outer shape to our cylinder. And then there's also this height cuts. So the height cuts are a way to kind of divide our cylinder and give it more edges. So right now there's 0 height cuts, so there's edges basically at the top and edges at the bottom. But let's, for example, just say we change this from a 0 to a 2. You can see now I've got additional edge loops around the middle of the cylinder. So once again, this creates a lot more vertexes and edges and faces that we can, push and pull and move around if we needed to. Okay, with that first cylinder created, with create shape still up there, let's go ahead and create our second cylinder. So let me just zoom out a bit, roughly place it, and I'm just going to shift click it into existence as well. So I've got 2 cylinders out there now. And let's click the new shape button again to close the window. And I'll go ahead and rename these. So I'm going to name the first cylinder as pillar 1 and the second cylinder as pillar 2. And let's go back to pillar 1 and let's move it into place. So I want to put it kind of toward the corner here, not all the way in the corner of this second room here. And that looks like, a pretty good location. So I'm at X of 5, Y of 0, Z of 5. And let's go to the second cylinder. And I want this to be roughly in alignment. So I can select this and set the X to 5 and the Y to 0 and the Z. We need to set that. So let's move this over to the other corner. Once again, constantly readjusting your view so you can see what you're doing. And let's maybe set this as a Z of 29. Okay, so they're in the same X, so they're going to be in alignment here. Now we want our second pillar to be taller. So once again, we can adjust the size using the ProBuilder shape script. So the size here is 3 of the original pillar and this pillar. And let's change that to a size of 6. Okay, and you can see it got taller. And if I actually zoom in here, you can see that it actually is kind of partially below the world now. So let me actually pull it up so it's based right on the floor. Now we'll create a platform to put on top of our pillars. So let me click on pillar 1 and move the mouse over to the scene view and tap F to zoom to it. To create the platform on top, we will go ahead and create a new shape. And we're going to go back to our trusty cube as the shape type. And we'll set this to 5 units in the X, 1 unit in the Y, and 5 units in the Z. So it's going to be a square, kind of 1 unit tall, that we'll put on top of our pillar. So let me go ahead and shift click kind of right in the middle of this. And that will go ahead and create it. And because my pivot is first corner, it kind of creates it off of the first corner, which, often we want, but let me just undo that. And if I select as center as the pivot and shift click it, you can see now it's going to be centered into that location. Okay, let me click off the new shape to get that out of the way. And we just want to make sure that this is actually right on top of our cylinder. Once again, make sure that you're on object selection, not one of the other selection types. And I want to just make sure that I am right on top of that. Okay, and there it's located there. So let's go ahead and rename this as pillar 1 top. And I'm going to make this a child of pillar 1. So let me drag and drop it into pillar 1. Therefore, if I ever move pillar 1 around, the top's going to come with it. Now we need to make a pillar 2 top, but a ProBuilder object you can just duplicate in the same way that you duplicate any game object in Unity. So let's go ahead and select pillar 1 top. And on Windows, we use Control D. On the Mac, it would be Command D to duplicate. And let's rename this as pillar 2 top. And of course, it's located on top of pillar 1. So let me drag and drop it into pillar 2. So it's a child of pillar 2, but it's still located over here. But if I actually go to the transform and just reset it to 0, 0, 0, now it's going to be 0, 0, 0 in relationship to its parent, which is pillar 2. So let me tap F here in the scene view to zoom to it. And you can see there it is, right by pillar 2, but it's, you know, at the base of pillar 2, not at the top of pillar 2. So we need to drag this up. So let's go ahead and drag this up until it's right on top of pillar 2. And once again, we want to kind of center this. Okay, there it's right on top. And it's not quite centered. You know, so sometimes you want to look at things from different angles to get it exactly the way you want it. And that's probably good enough. It's a little close to the wall. So let me go ahead and select, you know, pillar 2 overall, and just let's move it out a little bit. Okay, so there's our pillar 2, and our pillar 1 is here. Okay, so they're in alignment, but they're quite a ways away. Okay, and that's because we need to add one more platform here, and that's going to be a moving platform. So to create our moving platform, let's actually duplicate our pillar 2 top. Okay, so let me select that and duplicate it. And I'm going to rename this as moving platform. And it's a child right now of pillar 2, so let me drag it out of that so it's at the top level of our scene. And then I'm going to move it over. I'll move it kind of close to pillar 1 top, but with a little bit of a gap so the player has to jump. And right now it's at the height of our pillar 2 top. So let's actually bring it down slightly. Maybe right about there. Okay, so the player will have to get up on pillar 1 and then jump from there onto the moving platform. Then the moving platform will move over, and then they have to jump up onto pillar 2. So we want to make our moving platform visually distinct from our static cubes. So let's go ahead and do that using our vertex coloring. So let me bring up the vertex coloring window again, and I'll go ahead and apply a color. I'll just pick purple for this and go ahead and close that window. And last but not least, we need a goal object in this room. So once they get to the top of pillar 2, we're going to have a goal for the player, something for them to collect to win the level. So let's go ahead and bring up our new shape tool once again. And for this, I'm going to go ahead and pick a cone as my goal. And I'm going to go ahead and set its size to maybe 1, 2, 1. And let's shift click this into existence, kind of in the middle of our pillar 2 top. And I'll close my new shape tool and let's make this sort of hover. I'll move this once again kind of more in the center of this. And sometimes it's hard to tell if you're in the center without looking at it from multiple angles. So maybe right about there. And I'm going to move it up a little bit so it's, you know, hovering above the platform a little bit. And let's go ahead and rename this from cone to goal location. And let's give it a vertex color as well. And since this is the goal, we'll make it gold. Okay, our second room is now grayboxed. To stay organized, let's put all of our new objects into our grayboxed environment object. So we created our moving platform, the pillar 1, the pillar 2, and the goal location. So all of these objects and their children, let's drag and drop into the grayboxed environment just to keep things organized. And of course, I can close this off now and our hierarchy looks nice and organized. And let's go ahead and save our scene. They say a picture is worth 1,000 words, but perhaps a 3D scene is worth 1,000,000. Now that we have a Graybox level, you can literally sit down with your team and fly through the level in the scene view to discuss the level design, quickly iterate on it, as well as discuss what art assets and programming scripts are needed to implement the complete level. But since we're building an interactive game, what would be even better is a playable level. By having your Graybox level playable, you can actually playtest the layout to make sure the level design works, it's playable and fun. Getting our level playable is the goal of this video. Let's add our test player into our scene. You can find this within the project. If you navigate into Prefabs and then Player, you can see we've got our test player prefab here. And we want to drag this out into the scene. Of course, I can just drag it into the hierarchy and it's going to be placed arbitrarily. If I press F, it's placed way over here. Let me go ahead and reset its transform so it resets back to the center of the world. Tap F again to bring to where it is. You can see it's kind of right at the base of my world. So we need to move it over. And I'm going to roughly move this over to the location of my starting object here. Okay, and you can see that the test player actually has a camera as part of it because it's a first-person player, so we're looking out from the player's location, which means we no longer need our main camera. So let me select on the main camera, and let's delete it from the world. Now, if you click on test player, notice it's actually tagged as player. Several of our scripts use this tag to identify the player. Let's also create a layer for the player in case we want to set up unique physics interactions or camera rendering on the player. Some of our provided scripts do require this as well. So click the drop down under layer and let's add a layer as we've done in the past. And in layer, user layer 8, let's pick that location and type player as the name of the layer, capital P, all lowercase after that. And if we go back to the test player, make sure the layer is actually set as player. And it's asking us, do we want to set the layer to player for all of the children as well? I'm just going to say no, not for this object. So just the top level, not the camera, will be tagged as player. Okay, now since we placed the test player at the starting location, I could go back into my Grayboxed environment and select the player starting location, and let's just disable that because now we've got a player in that location. Let me go down and look at my player. Notice that it's a little bit low, so let me move it up here, and you can see it's basically a capsule with a camera inside of it. Now let's hit play to enter play mode and test this out. Okay, you can see I can move my mouse around, and that's the view into the world. I can use the WASD keys to move. So I can walk over to the first platform here and hit space to jump up on that platform, and then jump up to the other platform. And here is my key. Now we can't actually pick up the key. This is just, a rough Grayboxed environment, but we can see where the key would be. Presumably, in the actual game, we would pick that up, and then we can walk over to the door and unlock the door, walk through it. We can see our other platforming challenge here, and I can jump up onto our pillar here. I might have to double jump to get there, which, you may or may not want that. So that's a quick way to realize maybe an issue that we want to address if we don't want to require a double jump. And then I could jump up onto the moving platform, And then of course my moving platform doesn't move, but presumably as it moved across, you could tell I would get there, and then I could, jump and get to the goal. Okay. Okay, let's go ahead and exit playback mode. Okay, so if we think that our pillar 1 was too high, we can now quickly adjust that. So let me go to pillar 1 and type F to zoom to it. And I can see that I accidentally unnested the child objects when I moved them. So that was a mistake. So let me re-nest those. And, I can adjust the height of pillar 1. Rather than 3 high, I'll make it 2 high. And then, of course, I can move this down and then move the top down. Okay, then I can test again. And I'll just walk right over to the first pillar and jump. And you can see I didn't require a double jump. And I could jump from here up onto the moving platform. And I like that much better. Okay, let's go ahead and exit out of playback mode. You can see how you can quickly test and iterate on your level design using a Graybox level such as this. Let's go ahead and save our scene. In this video, we'll further enhance our blocked out level, making it more functional. We will also explore how you could enhance the look of ProBuilder created content using custom materials that we'll acquire from the Unity Asset Store. Often as a level designer, you want to prototype a level to a state that's functional enough to know if the level's going to work. One thing that's hard to determine right now in our blockout is the platforming challenge from pillar 1 to pillar 2 using the moving platform. It would be nice if the moving platform actually moved. Designers often work with programmers or program things themselves to get this sort of functionality in place within a prototype. You can do this to further test your level while you wait on your other team members, such as artists, to get their production art assets done. Let's set up the prototype moving platform quickly. Let me tap on the moving platform and tap F just so we can zoom to it. And what we want to do is we want to set up some waypoints that this is going to move between. So let me actually right click on the moving platform and create an empty game object, which will be, a child object of this. And I'm going to label this as waypoints. And then let me right click on waypoints and create yet another empty game object. And I'm going to name this waypoint 1. And just so we can see this waypoint a little bit better, let's give it a game object icon. So over in the inspector where there's the empty cube, let's click the drop down here. And I'm going to pick maybe the green triangle. And you can see here it shows the green triangle now in our scene view. So that's our waypoint 1. It's at the center of the moving platform as it currently is seated. So let me make a waypoint 2. So let me select waypoint 1 and duplicate it. And let's rename it waypoint 2. And I'll go ahead and change its game icon to maybe the red triangle. Okay, so we'll be able to see that. And I will move this waypoint to be much closer to the second pillar top. Okay, so maybe about Z of 11. Okay, our waypoints are set up, but they actually cannot be children of the moving platform since they'll be moving along with the platform as it moves. So let's move our waypoints to be outside the moving platform. So let me just drag it right outside of the moving platform. And then let's actually create another parent game object to hold everything. So since these are already in the Graybox environment, let me right click on Graybox environment and create empty. And I'm going to name this empty game object as moving platform parent. And let me move both the moving platform as a child of that and the waypoints as a child of the moving platform parent. Okay, now let's get the platform moving. So if we select the moving platform game object, not the parent, but the child object, and we need to add a component to this moving platform. So let's click Add Component, and let's search for Waypoint. And you can see there is a Waypoint Mover option here. So let's click to attach it. This is our waypoint mover script provided in our tutorial assets. It is the same script that the actual moving platform will eventually use. You often will build a library of scripts that you can use and reuse from project to project. The waypoint mover is one example of this. So within the waypoint mover script, notice we've got waypoints that we can set here. It's a list. So I can actually drag and drop waypoint 1 on the top of this list, and it will be set as element 0. And then we drag and drop waypoint 2, and that's set as element 1 in the list. Okay, you can also see we can set the move speed and the wait time in seconds. Okay, our moving platform is now set up, so let's test our scene by hitting play. And since our scene view is looking at the moving platform without even navigating over, I could verify that the moving platform is moving, and it's moving from waypoint 1 to waypoint 2. And let's make sure that we like the kind of location that it gets to. Okay, it's pretty close, but doesn't actually touch, so that's pretty good. So let me go down to the game view, and let's just run through the door and run over to the first pillar. And there's the moving platform waiting for me, and I can get on it, and it should move me right over to where I want to go. Okay, and it doesn't work perfectly yet because I'm not actually childed to the moving platform, so it kind of slides under me, but that's okay. That's something that will resolve in the actual game, but for the prototype, it's fine enough. Okay, let's go ahead and exit playback mode. We could spend more time getting other elements functional in our Graybox level, but we'll stop there for now. We have been using ProBuilder thus far for grayboxing our level. However, you can actually enhance the look of ProBuilder assets using fancier materials than the gray gridbox material. This is also a good chance to discuss the Unity Asset Store. The Unity Asset Store is a location where you can find, obtain, and even sell all types of assets to enhance Unity projects, from materials and 3D models to scripts, sample projects, and enhancements to the Unity editor itself. Most of the assets on the Unity Asset Store are created by third-party companies. In fact, ProBuilder itself started as a third-party product that you could purchase on the Unity Asset Store prior to Unity acquiring it. The Unity Asset Store has become a vibrant marketplace and is a great place to expand what you can accomplish as a game developer. We will use the Asset Store to obtain some nice materials for our project. To bring up the Asset Store, go to your Window menu and select Asset Store. Now this will open up the Asset Store tab here, and notice it says the Asset Store has moved. It's now a website. It used to be integrated right within Unity, but if you check this Always Open in Browser from Menu option, and then next time you go to Window and select Asset Store, it's going to go ahead and fire off your web browser and bring you right to the Asset Store page. Now feel free to browse the Asset Store, but I'll just search right for what I'm looking for. So at the top where it says search for asset, I'm going to go ahead and type world material free and hit return. And down in the search results, you can see the first thing in the search result is world materials free. And if you click on this, it will bring you to a page that further describes the asset. It's got various screenshots, additional description down here, reviews, and things like that. This asset happens to be free. Not all assets on the Asset Store are free. You can, once again, this is a marketplace. You can sell assets and you can buy assets, and people earn money off of these. But since this is a free asset, you should be able to click a button here that says Add to my assets. I've already done this, so mine says Open in Unity. But the first thing that you'll want to do is click that Add to my assets button. You will need to be logged into the Unity website for this to work. If you're not, you can log in at the top right corner of the web page. And once you've added it to your assets, the button should change to Open in Unity. And when it does that, go ahead and click this. And this will warn you that you're about to open something in the Unity editor, which we want to do, so we'll click Open. This will bring you back to Unity and open the Package Manager, which you've seen before. You'll notice that the world material free are now part of the packages that you've got available under Packages, My Assets. So once again, here in this menu, we've looked at Unity Registry before, and we've looked at packages in your project, but we haven't looked at My Assets. So My Assets are all the assets that you've acquired off of the Unity Asset Store. Okay, and you should now have world materials. Now, if this is the first time that you've added the world materials free, you likely have one of these arrows with the line, which means to download. I've already downloaded it, but you'll need to download. So you can either click on that, or there should be a download button up in the right-hand corner here. So go ahead and click that to download the package into your computer's hard drive. And once you do that, then you want to import the package into your project. So go ahead and click Import. This will bring up the standard Import Unity Packages window that we've seen before, where you can select what assets to include in your import. This package includes materials for all three rendering pipelines, but we just need the URP ones. So if I close these up so we can see them in their entirety, you can see the URP ones, shaders, and resources. So I could uncheck, the HDRP materials and kind of these top set, the built-in materials and so forth, and just include resource files, shaders, URP, scene and lighting, and URP materials. Okay, doesn't hurt to import all of them. You just don't need them. It might throw an error message saying that it doesn't work in your version of Unity, which you can just ignore because you're not using them. But let me go ahead and import as I've got selected here. And this will bring down all those assets and include them in my project. Okay, I can go ahead and close the package manager now. And if you look in the projects tab, there should now be a world material free folder, which has all the materials that we just imported. Let me go ahead and open that up. And there should be a scene called URP free demo scene. Let me just double click on this. And of course I want to save my changes to level 1. And this scene is just basically a sample scene that shows all the different materials that are part of this package. Okay, so you can see there's a lot of nice materials here, some tiles, some wood, brick, and so forth. Okay, so let's actually go back to our level 1 scene now. And I'm going to orient my view kind of looking maybe back into room 1, kind of, roughly from the starting location. Okay, within the ProBuilder tab, there is a button called Material Editor. Looks like a bunch of bricks. Let's go ahead and tap on that. This will bring up your material editor. And notice within this window, there is a material palette, and there's only one set to the lit material, and everything else has not been set. So what we want to do is set up our material palette to point to some of these new materials that we downloaded. So if I go back to my projects and then open the URP materials, you can see all of our materials here. And just for purpose of example, let me drag a few of these into these spots. So maybe I'll pick the bathroom tile material, place that there, and maybe the hex bricks material, place it here, and the wooden flooring, and place it here. Now that we've got some materials in our palette, we can apply those materials to our objects. You can apply materials using the object selection tool. So for purposes of example, let me just select the object selection and select the entire level floor and walls. And let's go ahead and apply the bathroom tiles. And this applies that to all the faces. Now you can also apply using the face selection. So let me select the face selection and maybe click on the floor. And let's apply the wooden flooring shader. And that just applies to that given selection. Let me click off so you can kind of see now that we've got a wooden flooring here. And if I look up, you can see the bathroom tiled walls. And of course, we haven't applied a material, to these platforms. If I, once again, use object select, I could apply maybe the hex brick, to these two platforms. And, relatively quickly, you can see I am changing that, Graybox grid material to fancier materials. Now, if you look at the material itself, it's tiling. And if you think the tiling is too small, once again, we can select the floor here And under ProBuilder, rather than bringing up the material editor, you can bring up the next option over, which wraps on my screen, but it's the UV editor. So let me bring up the UV editor window. And there's lots of interface here, and this is a fairly deep tool. But just as a quick jump into this, if you look under Actions, you can see tiling, and this is where we can set the tiling. And right now it's set to 1, 1, and there's these buttons below. So if I tap on 2 or 4 or 8, notice out on my scene view, my tiles are getting much larger. Okay, so let me select 4, for example, and close the UV editor. And once again, kind of select off of this so we can see it a little bit better. And you can see the wood pattern is tiled much larger. And I can do the same thing on the wall here. So let me just select this wall and bring up, once again, the UV editor. And let's do something like 8 so we can really see it, or 16. And you can really see that our tiling is much larger now. There. And I'll go ahead and close the UV editor and go back to object selection. Using these techniques, you can see how you can vastly improve the look of ProBuilder created game objects. This could allow you to use ProBuilder for more elaborate prototyping and perhaps for even some final game art. But I'm just demoing it for now, as we're going to actually replace our ProBuilder created art in the upcoming videos. So for now, let's just go ahead and save our scene. Now that we have a fully Graybox level, let's assume our artists have created some final art assets and made them into prefabs for us, while the programmers have added the necessary scripts to the prefabs to make them functional. We can now do an art pass. That is, we can pass over our blocked out level and replace the temporary art with production art. Sometimes this is done by the designer, artist, or programmer, but it often requires all three to collaborate on making sure the level both looks good and functions as it should. During this process, the nature of the art assets, feedback from playtesting, and many other things can change the way your level looks and functions from your initial design. We'll start this process by replacing the floor. Let's start by backing up our Graybox level in case we ever need to go back to it. So under Projects, in the Scene folder, we're going to duplicate our level 1. So once again, on Windows, we can Control-D. On the Mac, you could Command-D to duplicate. And we'll rename this new scene as Level 1-Blockout. And then make sure that the actual Level 1 is open, as this will be the scene that we'll continue to modify. Let's start by creating a new empty game object to put our actual game level under. So once again, we have our Graybox environment game object, and we're going to create a new one. So let's create an empty game object, and we'll name this environment. And we'll put our actual art pass elements within the environment game object. And just as we did before, I want to center this in the world. So I'll go ahead and reset its transform. So it'll be at 0, 0, 0. And then all the elements, all the child elements will be relative to the origin of the world. Our artist created 3D art objects for us, much like our 2D tiles in the 2D platformer project. That is, they were made to fit together, much like Legos. Let's go into the Projects panel and find the Prefabs folder. And within the Prefabs folder, we have our Environment subfolder. And within that, we've got a Building folder. And we've got various assets related to different types of buildings. And we want to go into the Astro building. We can use assets in these folders to replace our Grayboxed environment. And let's start with the floor. So if you open the floor subfolder, you can see there are various assets here. So we want to drag out an Astro floor prefab, which is a floor piece. And let me reorient my camera a bit here to remember where I'm at. I want to start kind of where the player starts. So let's find that starting location, which is right down here in this corner of the world. So you can see our test player there. So I'll go ahead and drag the Astrofloor prefab and place it out in my scene. And of course we can use our move tool to locate this. And I want to put this once again kind of right in the corner and bring it down to be, basically right at the same level as our floor. Okay. Okay, so I've got it basically right up to the wall on each side of the corner there. And it's essentially at the same height as the floor. Once again, as you're doing this, make sure that you are in the global mode under this toggle tool handle rotation option, and you've got grid snapping turned on. And once again, if I click the drop down here, I have my grid snapping set at 0.5, so half a meter snapping across all axes. And as we place things, you can see that the assets aren't perfectly aligned with our Graybox and the grid, but that's okay. Remember that grayboxing is just a reference, and we can deviate from it when needed. Okay, so we've got one floor piece here, and I'm going to go ahead and duplicate it to create another floor piece. And I want to, once again, kind of tile the world. So I want these to align with each other. And as we do this process, you're going to continually want to see the Grayboxed environment and then hide it. So, as I'm moving this, I can move it and, try to kind of snap it into place, but it's really hard to see. So let's take the Graybox environment and make it invisible. Now, we can actually, select it and make it deactivated to get rid of it, but this actually deactivates it in our game. So we can't see it down in the game view, and if we made a build, it wouldn't exist. And eventually we will do that. But for now, let's leave it active. And in the hierarchy, along the left side, notice there's a column with a little eyeball. This basically gives us the ability to hide things or show things. So as we're doing this process, we'll continually hide and then show. And when we hide it, it's still active. It's still part of our game. You can see it down here in the game view. It's just not shown in the scene view. Okay, so let me select that second floor piece, and I want to, snap it right to the other floor piece. And, with the grid snapping, that should work. We can also use vertex snapping, which I always like to do just to make sure that it really is snapped exactly. So if you recall vertex snapping, with a game object selected, you hold the V key down, and as I move the mouse around, it snaps to various vertices. So I always like to kind of go to the corner of the game object. So I'll use the upper corner here and then drag it over to the upper corner of the other floor piece. And there it is snapped in place. Okay, once again, we can, show the Graybox environment again and then hide it. So now that I've got two of these, I'm going to select both of them at the same time there in the hierarchy and then duplicate both of them. So I get two new ones, and now I can move both at the same time. And you're going to have to continually kind of zoom out here. And once again, I'll hold the V key down to do vertex snapping from the corner and snap the one corner to the other. And let's look at their Graybox reference again. You can see we're making some headway across our environment. Let's hide the Graybox environment now, and let's duplicate these two pieces to get two more. So now we're up to 6. And once again, we can move it out, then hold the V key down, and then snap it back. And if I show the Grayboxed environment again, you can see that these 6 pieces basically cover the entire row of the floor. Okay, let me kind of get a top-down view now. Okay, so I'm going to select all these floor pieces, all 6 of them, and then duplicate those, and then move them along the x-axis. And once again, if we hide our Graybox environment, we could then see what we're doing and snap them right into place here. Okay, now I've got 2 rows, so let me select all of the game objects in those 2 rows and duplicate just to kind of speed us up and get those right into place. And then let's duplicate those 2 rows again and move those right into place. And now, essentially we've got 6 rows along. If I turn my Graybox environment back on, you can see that it roughly covers the entire floor area. So we have a 6x6 grid of those Astro floor pieces, so 36 in all. Before we start adding our walls, let's take a moment to further organize our scene hierarchy. So under the environment game object, let's right click and let's create an empty object. And I'm going to name this floor. And I want to grab all of my Astro floor pieces. So let me kind of shift select across all of them and drag and drop them under the floor. Okay, and then I could just close the floor and not see all those sub pieces. The floor is now in place, so let's go ahead and save our scene. Take note that there are also ceiling asset pieces for the Astro building. I won't go through the process of putting in a ceiling, but you could, using the same technique as we just did for the floor. In this video, we'll continue the art pass, focusing now on the outer walls. Okay, let's go ahead and close off our floors folder here and open the walls folder. And you can see there is a wall bottom and a wall top subfolder. Let's start with the wall bottom. So this will be the pieces that connect to the floor. And you can see there's several different prefabs here. And let's select the Astro wall bottom. And over here in the inspector, notice there is a preview of these pieces. If this is down all the way, you won't be able to see it. So you grab this double line at the bottom and pull it up, and then we can actually get a preview of our prefab. So let's go ahead and drag out an Astro wall bottom, and let's place it, near the player starting position. So I'll drop it there and tap F to zoom in. And of course it's, way too high right now. So I need to bring it way down. Basically right at the floor level, and then it curves up. And I'm going to do this wall along here. So I need to rotate this properly. So let me rotate it by -90. And you can see that is angling properly. And let me turn off the visibility of my Graybox environment. And once again, we can kind of drag this to where we want it. Right to the corner here. Okay, so you can see that that piece basically goes from the floor and just angles right up. Once you have your first Astro wall bottom in place, let's go ahead and select it. Be very careful that you are selecting the parent wall bottom game object, not the child object. So these do have, a hierarchy with pieces down below. So just as you select things, sometimes if you click notice, it actually selected the child. So just always make sure you're on the parent and not the child. And let's go ahead and duplicate this. So we get a second one. And let me reorient my camera a little bit because I'm going to build this entire wall. So I generally like to, once again, move it, move the duplicate over and then hold the V in one of the corners and then snap it to the other respective corner. Okay, so I've got two of these now. So let me select both of them and once again, duplicate just to speed up the process so we don't have to do them one at a time, and move both over. Hold the V key down on the corner and then snap it into place. And then you can see we have a spot for two more. So let's duplicate the two that are selected, move them over. And once again, holding the V key down up on the corner, I could snap that into place. Now we've got a full row of the Astro wall bottom pieces. To complete this section of the wall, let's drag out the Astro wall bottom corner prefab. Astro wall bottom corner. You can see right here, it's basically the corner piece. This is a joiner piece between walls. So let me place it out here, kind of to the far left side of my wall. And once again, I need to rotate it. So let me rotate it in the -90 degree along the y-axis. And once again, let me hold down the V key up in the corner and I'll try to snap this to this corner. Okay. And you can see that it basically rounds along the wall and it will be a joiner to the other wall. Okay. So if we check our Graybox environment, once again, you can see that, our walls are going to come out a little farther than the Grayboxed environment walls, but that's okay. Once again, the Graybox is just a reference. Okay. Let's organize our hierarchy a little bit. So under environment, let's right click again and create empty. And I will name this new piece wall bottom. And I'll grab all of my Astro wall bottom pieces that I just placed and put that as a child of wall bottom. Okay, now let's start working on the top of the wall. So within our walls folder, notice there is also a wall top subfolder, and there's various types of wall tops. I'm just going to build everything off of wall top 1 standard for now, and later on you could go back and add some variety by adding some of the different wall tops. So let me drag out the wall top 1 and bring it out here near this corner. And once again, I need to make it in a negative 90-degree orientation to face properly. And this might actually be easiest to snap it to the right side so we don't have to deal with this corner piece to start with. So let me actually pull it all the way to the right, and let's tap F to zoom in. And once again, if I hold my V, I can find a corner down here and snap this corner to this corner below it. Okay, so I've got that whole piece there. And let's go ahead and duplicate this piece. And we're going to move it up. And once again, holding down the V on the corner, I could snap that corner to the next corner. And let's duplicate it one more time. Move it up. And holding down the V key, let's snap that corner to that corner. And let's turn on our Graybox once again, just as reference. And you can see the height of our wall is very close to the height of the Graybox wall. Okay. Okay, so you can see that here. Okay, let's turn off the Graybox once again. Okay, so we want to select all 3 Astro Wall top pieces, and let's go ahead and duplicate those. And once again, we can move them over and, just use snapping to get them right into place, or we can hold down the V key on the corner and snap the corners to the corners, as I like to do. And remember, we need kind of 6 total here. So I've got 2 of them. So if I select both of them at the same time and duplicate them, I could do two at a time here. And let's get these snapped into place and then duplicate one more time and move, and then vertex snap into place. And we've got that whole wall created. Okay, now we just need the corner. So there is an Astro Wall top corner piece right here. So let's drag this out roughly to where it needs to be. And of course, it's not oriented properly. And all these pieces we need to, for this orientation, go to negative 90 in the Y direction. And that puts it in the right orientation. And then we could, once again, kind of snap this into place. So I can go to the corner and vertex snap that to the respective wall top piece. Okay, so I've got one of those. Let me duplicate it. Pull it up. Use the V key to grab the corner here and vertex snap it to the piece below it. And once again, we'll do a duplicate, pull it up, and then vertex snap it to the piece below it. Okay, now we've got an entire wall created. Okay, our hierarchy is starting to look a little bit messy. So once again, within the environment, let's right click and create an empty game object. And I'm going to name this wall top. And I'm going to select all of my wall top pieces in the hierarchy and drag and drop them into wall top. Let's create one more holder game object within the hierarchy. So let's right click on the environment once again and create empty. And we're going to name this one outer wall. And we're going to place both the wall bottom and the wall top within the outer wall. Okay, so that basically contains all the pieces of this one wall. And now since we've got, one game object that contains the entire wall, I can duplicate that. So once again, this is, essentially a square world. So we're going to have 4 walls. So let's duplicate our outer wall. And on the duplicate, let's go ahead and change the Y rotation to 90 degrees. Okay. And you can see it rotates in this direction, which will make it a nice fit over here. And once again, we can reorient our view and then hold down the V key to get the upper corner here and snap it into place with the other wall. Now we'll repeat this process 2 more times to get our 2 other walls. So let me duplicate the outer wall here. And I'm going to rotate this in 180, so 90 more degrees. And you can see it's right there. and whatever view you need to kind of manipulate it. I'll hold the V key down here and snap it into place. And, always get a little close to make sure that it actually snapped properly. And we'll duplicate a fourth time, or a third duplicate, and we'll set its rotation to another 90 degrees, so that would be 270. And once again, we need to snap this into place. So holding the V key down up in the corner, I could then snap it right into place here. And once again, zoom in to make sure that it snapped properly. Okay, you can see now that we've got our floor and our walls in place. Once again, if I turn on the Graybox environment visibility, you can see we roughly, approximated what we had before. And now we've done a complete art pass across the floor and the walls. So one thing that we can do is open up our Graybox environment and find the level, floor, and wall piece that's now been art passed over. So for this piece, we can actually disable it because it's no longer needed. And let's go ahead and save our scene. In this video, we'll continue the art pass, focusing on the door and middle wall within our level. Our goal is to do an art pass over the door game object within the Graybox environment game object. So let's zoom our scene into the door. I'll go ahead and tap on the door and press F to zoom in, and then let me orient so I can actually see the essential door porthole here. We have a prefab for the door, so let's navigate within the Astro building. Let's find the door subfolder, and you can see the Astro door prefab here, which looks like a door with some wall around it. And let's just drag and drop it out into the scene and kind of roughly get it into place here. And let's back it up. And you can see that the door has its own curved bottom, which means it was designed to be used with the other curved pieces like the wall bottom prefab. For sake of time, we're not going to change our floors to match up with the door. Simply place the door in such a way that its floor isn't showing through the floor that already exists. You can just manually move down this game object slowly. Right there. So the floor is actually peeking through and we can see the curved surfaces here. Or if you look underneath here, you can see that this piece basically is right at the bottom of the floor. So you could vertex snap it to the floor piece that it's by. But that's a little difficult to do given all of the pieces that are here already. Next, we'll fill in the middle wall. This wall will be a lot like the outer wall, but we need the curved bottom on both sides of the wall since the player will be walking on both sides, unlike the outer wall. We have a special Astro wall bottom double-sided for this purpose. So once again, in the wall folder, you'll see under wall bottom, there is an Astro wall bottom two-sided. So let's drag one of these pieces in to our world. And once again, it may not be oriented properly, so we need to rotate it. So let me rotate it 90 degrees. And as you're doing this, you may want to turn off the door or make the entire Grayboxed environment invisible. So let's hit the I symbol to get that out of the way. And always make sure that we've got object selection mode. Sometimes if you click things, it'll, switch over to one of the face selection or vertex or edge selection. So just make sure you're always on object selection. And once again, since we've got snapping on, we should be able to just kind of place these pieces using the snapping since we're working off of the grid. Or you can always use vertex snapping as well. Okay, so we've got one piece in place. Let's go ahead and duplicate it and move it over. And once again, I'll use vertex snapping off the corner to snap it to the corner of the other piece. And duplicate again, move it over, and snap it right to the corner. And duplicate a third time, move it over, reorient my view here, and snap it to the corner. And duplicate again, move it over and vertex snap it right to the corner there. Okay, we've got that wall side done. You know, it may or may not extend beyond your wall. That's okay, because the player's never going to be outside of this environment. And let's create the wall on the other side. So I'll just pick one of these pieces and duplicate it and move over here and get that into place. We'll use vertex snapping here to snap that right into place. Okay, so we've got our bottom piece of the wall in place. And you can see as I'm working and selecting things, you know, it opens things up in the hierarchy, which, you know, sometimes gets a little confusing. So we've been working on our door here. So let's go ahead and create a new environment game object to hold these pieces. So let me right click on environment and create empty. And I'm going to create something called middle wall bottom. So this will include all of our astral wall bottom two-sided pieces. So let me shift select all of those and place those within that subfolder. Now we need to create the top part of the middle wall. We'll use the same astral wall top one standard prefab we used before. We need to place these both above the door and the wall. So I'll go ahead and drag one of these out here. And once again, it may not be oriented properly, so we'll need to rotate it 90 degrees to get it into place. And, you know, once again, we can vertex snap the corner to the corner. And once again, always zoom in, make sure that you've snapped properly. Now I'm going to kind of fast forward through this part as I duplicate these and vertex snap them into place to create this entire wall. Okay, I have the entire wall in place. Let's go ahead and replace one of the astral wall top one game objects with one of the variants, just to demonstrate how you might do this. So I'll select one of the astral wall top one game objects in the lower middle of the wall near the door here. So not the bottom piece, but the piece above it is one of the astral wall pieces. And with that selected, I could go over to the inspector and I'm going to copy its transform so I know its exact location. So let me go ahead and copy the component, which will bring in, the position and the rotation and the scale into the clipboard. And we're going to delete that current game object. So let me delete it from the hierarchy. And it blows a hole here. And then let me find the astral wall top 5 window. Okay, and I can drag it out into the world. Doesn't really matter where I place it because I'm going to go to its transform and click the ... go down to paste, and then paste the component values, and it should snap it right into the place of the former astral wall top 1. Okay, so now we've got a nice wall piece that has a window where the player can look from one room to the other. And you could do a similar process, to bring in vents or paneling or the screen, just to vary your environment. Let's clean up our hierarchy a bit. Within the environment, once again, we can close up some of the subfolders just to make it less messy. And I will right click on the environment and create an empty. And I'm going to name this middle wall top. And let's drag in all of our wall top pieces that we just put in the world and drop them into middle wall top, and we can close that off. And let's create yet another empty game object within the environment. So I'll right click on the environment and create empty, and I'm just going to call this middle wall, and that's going to contain the bottom and the top in the middle wall and the door. Okay, so I'll put the door in there as well. Okay, the art pass on the door and middle wall should now be done. Once again, we could go back to our Graybox environment, find the door game object and deactivate it because we've now done an art pass over that. And now we just have to replace the inner elements. But for now, let's go ahead and save our scene. In this video, we'll do the art pass on the elements within the first room in the level. Within the Grayboxed environment game object, we can see the remaining elements that we need to do an art pass on, including platform 1 and platform 2, which are part of our first room. As we do the art pass, it may also be helpful to turn off the visibility of the outer walls, because they kind of get in the way as we're placing things. So to do this, we can turn off the visibility of all these outer walls, but I'll actually make a parent object. So let me right click on environment and create empty and make one object called outer walls. And then I'll place all of the outer walls within that game object, just so, I've got less steps to turn on and turn off the visibility. Okay, so I'll turn off the visibility right now. They're still in the game, but we just can't see them in the scene view. And this is just, an organizational thing to help us place things and not have other things in the way of our visibility. Okay, so here's platform 1 and platform 2 that we're going to do an art pass upon. So within the project tab, let me close up the building for a moment. Notice that we've got a platforms subfolder. So let's open that, and there's various platforms in here. And I'm going to use platform A. So this is what it looks like. Let me go ahead and drag and drop this into the scene, roughly where platform 1 is. And I could tap F to kind of zoom in, and let's move it down to be, right about the same height, and then move it over. And that looks pretty good. So let's go ahead and select platform 1 in our Grayboxed environment and disable it now, because we've effectively replaced it with the new platform in our art pass. Let's go ahead and rename platform _A as platform 1. We'll do the same process now for platform 2. That is, we'll drag in another platform A prefab and drop it out here into the world, close to the top of platform 2. And I'll tap F to zoom to it. And once again, we'll use the move tool to position it, roughly in the same spot as platform 2. And once we have that done, we could go ahead and disable platform 2 in our Graybox and then rename platform A as platform 2. While we are working on room 1, let's also replace the key placeholder here. So if we navigate once again into our prefabs, we've got a pickups folder, and one of the subfolders are keys. And let's drag our key A to be, roughly in the same spot as the box here. And once again, we could, kind of place it right in the middle if we wanted to. And with that out there, we could then disable the key to door prototype object. And then let's go ahead and rename keycard A as keycard. And let's clean up our hierarchy a bit. So within the environment, let me right click and create an empty game object. And let's name this room 1. And we'll move all of the environment objects that I just added, including platform 1, platform 2, and the keycard, and place those within room 1. Okay, the art pass of the first room is complete. Let's go ahead and save our scene. In this video, we'll conclude the art pass by replacing the elements within our second room of the level. Let's start by repositioning our scene view so that we can see clearly into the second room. Let me zoom out here a little bit and pan over. Okay, so we're going to replace the Grayboxed assets on this side of the middle wall, starting with our pillars. So let me tap on pillar 1 and press F to zoom to it. Within the project tab, we can navigate to environment and go back into the buildings. And within our Astro building, we actually have a pillar subfolder, and it's got a variety of prefabs here. It's got a Astro pillar full, Astro pillar single, and then the individual parts of the Astro pillar. So we'll start with the Astro pillar single, and let's go ahead and drag this out into the environment. And we want to roughly place it where the current pillar is. And once again, you might have to reorient your view a bit to get this, kind of in the center. of the previous pillar. It doesn't, once again, doesn't have to be exact, but an approximation. And I'll go ahead and rename this as pillar 1. And we also need to replace the pillar 1 top. We'll use a floor piece for this. So within our floor area here, let's just drag out an astro floor, and we'll put this out into the environment. And then let's go ahead and move it. And we want to place this so it sits on the pillar top. So that's the right height. And once again, kind of getting it about centered, approximate to what the old one was. Okay, and you can see, this is a little bit higher than our gray box, but we'll just go with this for now. And of course, we can test it when we play test and see if it works or not. Okay. Let's go ahead and rename this astro floor as pillar 1 top. And just like we did in the Grayboxed, I'm going to make the pillar 1 top a child of pillar 1. And I will also now disable the Graybox version, since we've now done the art pass to replace it. Next, let's replace pillar 2. If I click on pillar 2 here and tap F, we can zoom over to it. And once again, there is an astro pillar full. If I drag it out here, you'll notice that it's actually pretty tall. So if I drag it so it's on the ground, it sticks up quite tall. So rather than use the astro pillar full, let me go ahead and delete this. We will build a pillar using the parts here. So let's drag out the astro pillar bottom, which you can see is just basically this bottom part. And let's place this, roughly by this, and we can move it later. And then let's drag out the top piece. And once again, we can get it close, and then we can zoom in and get this placed properly. Might have to use, vertex snapping here to snap it into place. Okay, so with both of those pillars created, let me just create a new game object. So let's create empty, and I'm going to name this pillar 2, and I'll place the bottom and the top within pillar 2. So they're all within a parent object. Now I should be able to easily move this into place, roughly on the same location as our Graybox version. Okay. And you can see we've got the base created. Now we need to create the pillar 2 top. So once again, we'll use the astro floor for this. And let's bring it out into the environment. And then let's move it into place. And that looks good. And now that we've done the art pass, we can go to pillar 2 in our Grayboxed environment and disable it. And of course, we can rename our astro floor as pillar 2 top, and I'll drag and drop this into that parent object so it's all together. Next, let's put in our moving platform. Within the project tab, let's navigate to environment, and there is actually a subfolder for moving platforms. So let me tap on our moving platform parent here and press F to jump to it. And we'll go ahead and drag out this entire moving platform. And once again, roughly place it in the scene. And then we can, adjust its positioning to get where we want it. And once again, we've got snapping on, so it will snap. If you ever don't like exactly where it's snapping, you could turn snapping off and then more precisely place the object. Okay. In general, I'll keep snapping on, but you could always turn it off for individual placement. Okay, let's go ahead and disable our moving platform parent placeholder now that we've done the art pass on it. And if we look at our new entire moving platform game object and open the cascade, you'll notice that it's a parent object. It doesn't really have any components other than the transform. And within it, its children are the actual platform itself, and then a subfolder of waypoints, which is much like how we set up our moving platform parent above. And if we open up waypoints, you can see there's actually one waypoint already included. I'm going to go ahead and relabel this as waypoint 1, and I can change its game icon to be our green triangle, since this will be the first one. And just like before, we need to create a second waypoint. So let me just duplicate this to create another game object, and I'll rename it waypoint 2, and I'll change its game object icon to the red triangle. And once again, if you zoom in a little closer, you can actually see these. Let me pull this one out and just move it along the Z-axis. Once again, we want to place this, about where the other one was, and we already disabled it. So let me turn it back on so we can see the other waypoint. And, I can put this, roughly in the same location where that one was. Okay, let's go ahead and disable that again. So it's kind of nice to keep your placeholders around if you ever need to go back and look at them. Now I've got both waypoints in place. And if I now go to my platform_E game object and look at it, you'll notice that it actually has the waypoint mover script on it in the inspector. So this is the same script that we used previously. And if I make this a little bit bigger, we can see that the first element is already set as waypoint 1, and we could just drag and drop the second element in the list to be waypoint 2. Now the moving platform should move between these two waypoints. Notice the move speed and wait time are already set in the waypoint mover script component. So let's go ahead and test this out. Let's press play and see if it works. Okay, and I'm just going to look at it and see the waypoint is moving from waypoint 1 to waypoint 2. It kind of seems a little slow to me. So right here in playback mode, I can go down to the component and let's change the move speed from 1 to, let's say, 5. Now it's moving quite a bit faster, maybe a little bit too fast. So how about we go to something like 3? And at 3, that seems like a more reasonable pace. So let me go ahead and exit playback mode. And when I exit playback mode, remember all your changes that you make during playback mode get reset. So my move speed went back to 1. So I like 3. So now in edit mode, I can change this from a 1 to a 3. And that will then stick. So when I go back into playback mode, it will now be set to 3. Okay, lastly, we need to replace our goal placeholder. So here's the goal location. Let me select it and tap F. This was the little cone that we placed on top of this platform. Now, if we look back in our prefabs, we have a pickups folder, and one of the pickup subfolders is called other, and within that we have a goal pickup. Okay, and it looks like, maybe some crystals or something. So let me go ahead and drag and drop that roughly, on top of this pillar in the same location as our previous goal location. And that looks, about right to me. So let me select the Graybox gray location and let's go ahead and disable that now that we have our goal pickup in place. Now our hierarchy is starting to look a little bit disorganized again. So let's take another moment to organize it. Let me right click on the environment and create an empty game object. And I'm going to name this room 2 since we've been working in room 2. And I want to grab all of my room 2 environmental art assets that I just added. Pillar 1, pillar 2, the moving platform, and the goal pickup, and drag and drop them under room 2. With that all in place, we've finished our art pass, but we need to turn on the visibility once again of the outer walls. So we see the outer walls. And I also want to set up my layers for my environmental assets. So let me select the top level environment game object. And right now you can see it's just on the default layer. So let me go ahead and add a layer like we did for the player layer. And I'm going to pick user layer number 7. And I'll just type in environment here to add that layer. And if I go back to my game object, I then need to set the layer to the environment. And when I do that, it's going to ask me if I want to propagate that change to all of the children. And yes, I do want to do that because I want all of the children of the environment game object to be on the environment layer. So now if I click through these, they'll all be on the environment layer. All right, let's go ahead and save our scene. In this video, we'll add the full first-person shooter player into our level and begin playtesting with it. Okay, let's select our test player and move our mouse to the scene view and tap F to zoom to its location. So there it is. And I'm going to go ahead and copy the transform of the test player. So I'll hit the ... over here in the transform component and go to copy component. Now over in my prefabs, let me find the player folder. And here is our FPS player. So let me just drag it out into the world. Once again, the position doesn't matter because I'm going to go to its transform now, click the ... and go to paste component values, and it should snap right to the same location as our test player. And now that we've got it in our location, we could, delete our test player. So let me right click on the test player and go ahead and delete it. And now with our FPS player in place, we could, adjust the position as needed. One thing I don't like is, the player starts looking at the wall. So let me go ahead and rotate around the Y-axis here, just to get it looking into the room when the game starts. Something like that view. Okay, let's look in the inspector. Notice that the FPS player is already tagged as player. Make sure the layer is also set to player. We set this up for the test player, and it was in layer 8, and this was already tagged to layer 8, so it already is set up. Unlike the test player, the FPS player also has controller support in addition to keyboard and mouse support. So let's go ahead and test this out. To get the full effect, I'm going to change from play focused to play maximized and go ahead and hit play. Okay, so let's navigate through the environment here, jump up on the platform, and then jump to the other platform. There's the key card. You should get a little sound effect when you get to that. And let's go to the door, and it is currently closed. If I get to the door with the key, notice it turns green and it opens. Get a little sound effect. And then here's our pillar 1. Let's jump up onto that. And there's our moving platform. Let's jump onto the moving platform. And it should nest us on that and carry us across. And jump up and get our goal. We get a little sound effect. The goal isn't completely set up yet. We will rectify that in a moment. But you can see our level is pretty playable with the art pass done. Okay, let's go ahead and exit playback mode. And I'll switch my play maximized back to play focused for future testing. And let's go ahead and save our scene. In this video, we'll go over the FPS player prefab in detail so you can understand how it's set up. Let's start by selecting the FPS player game object in the hierarchy. This is the player in our scene. If you look into the scene, you can see it's made from a capsule. In the inspector, notice there is a capsule mesh filter and a mesh renderer component, which defines what the player looks like. Since this is a first-person character and the camera is looking out from the capsule, the player never actually sees the capsule directly, but it does interact with the level lighting to cast shadows as the player moves around. If I scroll down a bit in the inspector, notice the player has a character controller component. The character controller is actually a special type of capsule collider for characters. This collider, among other things, prevents the player from passing through other game objects with colliders on them, such as the floor and walls. The player also has a rigid body component, which can be used for physics interactions, such as applying force to the player. Notice that use gravity property is turned off as we move the player using a combination of the character controller component and the player controller script. Also notice that the rigid body's collision detection mode is set to continuous. The default collision detection mode in Unity is actually discrete. It is computationally efficient, but does not work well for detecting collisions on objects that move quickly, such as the player, moving platform, enemy, and projectiles. So we set it to continuous. The player controller script component is what moves the player based on the actions of the player. You can control the speed of the player, how high it jumps, how much gravity affects it, as well as the input action bindings. And you can see these are set up for both keyboard control as well as controller support. There's also a health script component that controls the health of the player, as well as the death and hit effects on the player. We'll look both at the player controller script and the health script in more detail in an upcoming video. Now, if you open the cascade on the FPS player, notice it has various child objects, and one of those is the camera. Let's go ahead and click on the camera. You get a preview of the camera here in the scene when you click on it, and of course that preview is the same thing that we're seeing down in the game view. You'll see in the inspector that we have a modified URP camera component where you can define the various camera settings here, the projection, rendering options, etc., etc. The camera also has an audio listener component, which is the player's listening ears in the game. And if I scroll down a bit, you can see that we also have a camera controller script component. This is a relatively complicated script under the hoods, but it has some useful properties exposed in the inspector, which you can use to make the camera more fitting for you. For example, you can invert the camera controls. You can also adjust the speed with which you look around. And you can also see the input actions here defined, which tie the camera movement to the mouse and to the right stick on your controller. Now, if we look at the children of the camera, so expand it if it's not expanded, you'll see that one of the immediate children of the camera is the shooter game object. So let's go ahead and select that. The shooter object has a shooter script attached to it. This shooter script component controls which guns are available to the player. You can see the gun options here if I open this up. Notice there are 3 guns set in the guns list. The script also has input actions for using the guns. Notice there are settings for firing the gun as well as changing which weapon the player is using. Beneath the shooter game object are gun holder objects, such as the player pistol. Let me go ahead and select the player pistol. This game object actually has a gun script on it. This component controls lots of settings for the gun. So you can see there are prefab settings here, which relate to the projectiles and effects of shooting the gun. So you can see the projectile game object is set here. This is what actually shoots out of the gun. There's also a fire effect that is created when the gun is shot. The fire settings control how the gun fires. There's a fire location transform. This is where the projectile for the gun will be emitted from. Since each gun may have a different location projectiles should come from. The fire delay controls the fire rate, and the fire type controls whether the player has to press an input every time they want to shoot versus holding down the fire key and automatically shooting. The maximum of fire controls how many projectiles the gun shoots each time it's fired. And then the maximum spread degree controls the spread angle of the projectiles when coming out of the gun. The equipped setting contains one of the most important settings for the gun, and that's the available checkbox here, which determines whether the player can actually access and use this gun. If this is checked, the player can use the gun. But if it's not, the player can't use the gun, even if it's in the shooter list back on the shooter game object. You could use this to set up guns that are not available, that become available maybe through a pickup, for example. And then scrolling down, the animation settings help apply the animations to the gun. The gun animator is the actual animator on the gun. The shoot trigger name is the name of the parameter that the animator uses to know that the gun is shooting. This should exactly match the parameter in the animator that controls your gun animations. And then there's the idle animation name, which should be exactly the same as the name of the idle state in the animator. It's used to tell when the gun's finished animating, so your gun can shoot again. And then there's various ammo settings here. Notice it's a checkbox if you want to use ammo or not. If this is not checked, the gun basically has unlimited ammo. But if you want to have limited ammo, you would check this option. And then there's various settings for related to ammunition ID, which is a pickup that you can pick up out in the world. And if the gun needs to be reloaded and what the size of the magazine is, and et cetera, et cetera. Now, if you open up the player pistol game object, you'll see it has a child component, and let's open up its child component. And you'll see it has several child components, including the actual model of the game that the player sees, as well as a fire from game object, which is the location that we will fire from out of the gun. Let me zoom in to show where that is. So you can see the fire from is right on the end of the pistol. So projectiles will spawn here, and different guns might be longer or shorter, so this location will vary. You can see, in addition to the player pistol, we've got two other guns. There's the electro gun and the shotgun. Each are set up in a similar fashion, but have their own unique settings. If you wanted to create a new gun in the modifications portion of the assignment, you can duplicate one of the gun prefabs and use it as a template that you can modify off of. Just remember to add the new gun to the shooter's list of guns. So once again, up in shooter, we've got the shooter script, and it's got your list of guns here. So you would add to this list. With that, I hope you have a bit more understanding of the fairly complex setup of the FPS player prefab. Animation is one way to polish and add juice to your game. The pistol currently does not animate within Unity. It turns out that our artists created animations for the pistol within their 3D modeling tool. They exported the model as an FBX file and provided that file to us within our assets. FBX is a standard file type for 3D content that most 3D tools support. Unity allows you to import FBX files, so we have the animations. They just are not set up yet. In this video, we'll go through the steps of setting up animation that comes from an FBX file. Let's start by entering play mode and shooting our pistol. So if we look at our pistol there in the scene, notice that it's not animated. We're just moving it around with the player. And of course we can shoot. You can see the sound effect created there in the scene. And there is actually a little particle effect that comes out. And then of course the projectile shoots out. Okay, so what we want to do is we actually want to animate our gun to start with. So let's go ahead and exit play mode. And open the FPS player in Prefab edit mode by clicking the little arrow here to the right of the FPS player. This will bring us into Prefab edit mode while still being able to see kind of a grayed out version of the background environment that the player sits in. We're going to first focus on how animations are brought into Unity. Click on the player pistol under the player pistol holder. So if I open up the shooter, notice this is actually called player pistol holder. Let me open that up and click on player pistol. Notice that this already has an animator component on it with the controller set as player pistol. Let's go ahead and open the animator. And if we look at it, you can see the animation tree and parameters have already been created and positioned. So if I go over to parameters, we can see there is a shoot parameter. And on entry, we go to idle. And then from idle, we can go to shoot, based on the shoot parameter being turned on. And then it goes back to idle. Now, if we actually click on these states, notice that the motion property has not actually been set up for either idle or shoot. We'll need to specify animation clips here. Let's go ahead and go into the Projects tab and let's navigate into Art. And within Art is the FBX imports folder. So let's open that up. This folder contains FBX files of most of the 3D assets in the game. You can load these assets into a program such as Blender if you want to modify them. For now, let's look inside and find the player pistol folder. Let me open that up and let's make this a little bit bigger. Here are assets for several varieties of pistols that you could later integrate into your game. The one that currently is in the game is called player pistol right here. Let me go ahead and select that. The inspector for FPS assets contains multiple tabs for model, rig, animation, and materials. Go ahead and click on animation. And if you scroll down here, you can see there are various animation clips. There's a pistol idle and a pistol shoot. These were animated in a tool like Blender, and when the FBX was exported, the animations came along with it. Now, if you actually open the cascade arrow on the player pistol FBX file, you can see its subcomponents right here in Unity, and toward the bottom are the actual animation clips. So once again, the player pistol idle is represented here, and the player pistol shoot is here. And you can even preview these down here in the preview by pressing the play button. You can see the idle, the innards of the gun are rotating. And if I go to shoot and play that, you can see the gun just sort of has a recoil effect. Now we could use these animation clips as they are, but if we want to be able to edit these animations within the Unity animation tool, we can't use the ones directly contained in the FBX file, because Unity cannot modify the FBX file directly. To get around this, we can create copies of them the same way that we created copies of anything else in our project file. So let's select both of these animations and let's duplicate them. So once again on Windows, we Control D. On the Mac, it would be Command D. Notice it created duplicates above the FBX file because it can't, once again, modify the innards of the FBX file here, which is represented under the cascade. So let me uncascade that now. Now these are just regular animation clips that we could modify within Unity. We often want to be able to edit the animations our animators provide for us, so taking the time to duplicate the animations is good to do. This is especially true if we want our animations to loop, but it hasn't already been set up to do so. Thankfully, in this case, our animator have set up our animations how we'd like them. So if you click on the pistol idle, notice it is already set to loop, and pistol shoot is not set to loop because it just plays once. Now that we've brought in the animations as separate animation clips, let's move them into we've got a folder for animations under Art. And within the animations folder, we have a pistols subfolder. And within that, we have a player pistol folder. And this is where the animation controller is. So let's go ahead and move those two clips that we just duplicated up into this folder, just so we can find them easily. So let me select them here and just drag and drop them up into that subfolder. Now let's attach them to the proper animation states in the animator. So over here in the animator, let's click on idle, and we want to set the motion of idle to the pistol _ idle animation clip. So I can just drag and drop this right there. And then let's go to the shoot state, and we want to do the same thing here. So let's drag the pistol _ shoot animation clip into the motion property. Now if we select the player pistol game object here in our hierarchy, the one that actually has the animator on it, we can then open the animation window, and right here we can actually see the animations on this with all of the different keyframes, and this is where we can actually edit this. And of course I can switch from this to the pistol shoot, and once again, we can scrub through. If you're looking in the scene view, you can actually, see these things take effect depending on what animation clip you're on. And once again, these are all editable now. Let's go ahead and exit Prefab edit mode by pressing the left arrow here in the hierarchy to go back to the top level scene. And let's enter play mode now to check out our new animations. Okay, you can see just the idle playing here. So the innards of the gun are rotating. And if I click to shoot, we can see the recoil animation play there. Okay, and of course, as this is happening, if you go into the animator and select, the appropriate game object, you should be able to see the animator states actually playing from idle, transitioning to shoot, and then back to idle. Okay, let's go ahead and exit play mode. Okay, we've got our animations now set up on our pistol. So let's go ahead and save our scene. So far, we've only created solid 3D objects in our game. In this video, we'll discuss creating particle systems. A particle system allows you to simulate non-solid, fluid-like entities such as smoke, fire, explosion, splashes, and dust clouds. Particle systems work by emitting mini particles made up of either 2D sprites or 3D meshes in the scene over time. Particle systems are a great way to add further visual polish and feedback for the player. In this video, we'll create a visual effect when we shoot the pistol using a particle system. Let's start by switching back to our scene view and our game view here in the editor. Within the hierarchy, let's select the player pistol holder game object under the FPS player. And once again, this is where we've got the gun script, which defines a fire effect. So we've got the pistol fire effect prefab set here. And if you actually click on this property, it will select it over in your project. So that's kind of a quick way, to locate things. Here is the prefab. And if we actually double click on this, we could go into prefab edit mode. Now, if you look in the inspector, you can see that it's set like our other effects across the project, including having a timed object destroyer script that destroys the object after a predefined amount of time, in this case, 1 second. It also has an audio source component, which plays a sound effect when the pistol's fired. In this case, it's the pistol shot audio clip. And if we scroll down, you can see that there also is a particle system component on this object, which creates sparks that come out of the pistol each time it's fired. You can preview the particle system in the scene view. If I actually click play here, you can see that. You can zoom in a little bit perhaps on this and press play again, and you could see that play out. Stop and play. What we want to do now is add another particle system to go along with this effect, to also add some smoke coming out of the pistol when the player shoots. Now, to hold this particle system, we'll create a child game object underneath the player fire effect. So let me right click on it and choose create empty. And we'll name this game object puff of smoke. And on the game object, let's go ahead and add a component. And what I want to do is add a particle component. So if I start to search for particle, you can see particle system is one of the options. So let me select that. Now we've got the particle system component with a bunch of settings here. And there actually is a preview of this as well. So let me just stop it and press play again. And you can see a particle effect happens. Of course, we haven't set it up yet, but there's one here. Let me go ahead and stop that. So let's go through and start to set up some of the settings on the puff of smoke particle system. Okay, the first thing that we're going to do is we're going to go down to the start lifetime. And this defines how long each particle will exist. Right now it's currently set to 5 seconds. Let me change this to 1. And if I left this in play mode, you can see that the effects that are changed kind of take immediate effect. Let me scroll down a little bit here. And you can see there are various sub-effects here. And each of these contains a lot more options. So if you click on these, they open up to show you additional options. And of course, the checkbox means it's turned on versus the missing checkbox means it's turned off. Now, the larger visual effect of the particle system is achieved by spawning many simple 2D images or 3D meshes. We're going to be using a set of sprites for this particle effect. So let's first tell our particle system what it should be rendering. So if we scroll down to the rendering option and open it up, you can see there's various sub options here. And let's go to the material first. Notice there's nothing set. Let me go ahead and hit the target here. And we want to pick the sprite default material. So I can start by searching for it. And you can see the sprite default material right here. So let me go ahead and select that and close this off. And now it's set. Once again, you can see the immediate effect over here. Now let's give the particle system the sprites to use. So let's scroll up a little bit and find where it says texture sheet animation. And let's go ahead and check this to turn it on and then open it up. And where it says mode, let's change that from grid to sprites. And then we can specify a sprite here. So let's go ahead and click the target. And we want to search for explosion. And you can see we've got various explosion sprites already in our project. And I'll select the first one here. So explosion sprites _0. And I'll close this off. Once again, we can see the effect over here. Looks more like the silhouette of a cloud rather than a box. In the texture sheet animation options, we can add more spots for additional textures. So we can actually click the little plus here, and we're going to add explosion 1. And once again, we can just keep adding these. We're technically going to have explosions for all of them. Once again, remember you can click on these and it will show you over in the project what's selected. So here's 0, 1, 2, and 3. Okay, so if I go back to my puff of smoke, scroll back down to where we're editing, we could just drag and drop 2 and 3, which would be a little faster to do that. So now as these particles play out, they're going to be cycling between those sprites, so it creates a little bit of animation on them. This is a good start for our puff of smoke for when the pistol fires, but we want to change a few more things. We want the particles to emit in a different direction. We want them to move down and out more. We also want the effect to be a burst of particles rather than a constant stream. Lastly, we want the effect to only happen once. Right now you can see it loops forever. Let's start working on these issues with the shape of the emission first. So let's go ahead and find the shape dropdown and open that up. And you can see the shape is currently a cone. If I actually zoom out here, you can actually see that cone that the particle is emitting from. This is handy for visualizing our adjustments to the shape. We want to leave the shape as a cone, but we want to change the scale of the cone so that it's a little smaller to fit the front of our gun. So let's go ahead and set the scale of X and Y from 1 to 0.1 in both X and Y, and you can see that the cone got much smaller. If I zoom in here, you can still see it's a cone, but it's way smaller. And let's set the Z component to 0.025. This gives us a flatter cone where the particles go out more to the side than they do forward. Next, let's make the particles happen in a burst. If we open up the emissions drop down here you can see that we have a rate over time option. If we increase this, it will make more particles that are created every second. So let me just make it to something like 50. If we decrease it, we'll have fewer. So let me make it something like 2. Let's go ahead and change the rate over time to 0. Now we have no particles being produced. We could make single bursts of particles instead of a constant stream by adding to the list of bursts down below here. So let's click the plus here once. Now in the scene view, it will create this burst periodically to simulate the effect for us, since we still have it set to loop. This is already starting to look like a nice smoke effect. It seems a little crowded though. Let's reduce the number of particles that are emitting in this burst. Let's change the count from 30 down to 5. The effect looks a little bit better now. That being said, there's still not a lot of variety in the individual puffs yet, and they all come out in the same burst. It looks a little too uniform. Let's add a second burst to help break up the uniformity. So let's hit the plus again, and let's change the time option to be 0.1, so this will burst a little bit later, and let's change the count to be 10. Now we have a nice spread of particles, and our particle system is, about halfway set up. So let's go ahead and save our scene. Let's continue to set up our particle system. Next, let's change the size of our particles to make them more varied. If we open the size over lifetime dropdown, which is right here, and turn it on so we could set the settings, you can see that we get a curve here. The curve controls the way the particles resize over the time they exist. We want these to start large and end small. The default is actually the opposite, so start small and end large. So if I click on the curve here, I can then edit it down below, And you can see there are various presets. So I can actually click this preset where it starts high and then goes down over time. And you can see the effect immediately where the particles start large and then get smaller over time. But the size might be starting a bit too large. So rather than being at 1, let's go ahead and drag this down to something like 0.5. Now, another way you can do this is you could actually change the scale. So rather than 1 here, I could click on it and type 0.5, and that will bring it down. And then I could put my keyframe, all the way at the top to be 0.5 as well. Of course, the particles are still all doing the same thing, so it still looks pretty uniform. So let's go back to the top of our particle system component to look at the base options. Look at the start size setting. You can see it's set to 1, but there is also a drop down next to this option. Let's go ahead and click the drop down here. And you can see there are several ways to control the starting size of the particles. Let's select random between 2 constants. Then let's change the low value to 0.5, and we'll leave the large value or the second value to 1. We can see that we get more variety now in our particle sizes out in our preview. We could do the same thing for color. So click on the drop down next to Start Color, and let's select random between 2 colors. Let's click on one of the colors, and let's make it a dark gray. And let's click the other color and maybe make it a light gray. And you can see it's looking much more like smoke. But, it's fairly opaque. So let's go back to these colors and not only change the color, but also change the alpha value. So let's go from completely opaque, which is 255, down to very transparent. So I'm going to make it something like 50. Okay. And we need to do it for both colors here. So let's set this one also to 50. Close that. And once again, in our preview now, we can see both the color and the transparency. Once again, looking much more like smoke. Now, near the top of the particle system, you can see we've got this loop option here. And let's go ahead and uncheck that now, because our particle system should just play 1 time. It is kind of nice to have looping on while you're building your particle, so it's constantly playing. But with looping off over here, we'll have to click play to see it, and then stop, and then play again to see it again. Okay, we've set a lot of settings on our particle system, and we previewed it here. But of course, it'd be nice to play test it in the actual scene, in relationship to shooting the gun. So let's go ahead and exit prefab editing mode. And let's go ahead and press play. Okay, when we shoot, we should be able to see our new particle effect. So the pistol fire effect, of course, has the old kind of sparks coming out, but now we can see the puff of smoke as well. The particles still linger a bit too long for my taste, so let's shorten how long they're sticking around for. Let's go ahead and exit play mode. And we need to go back to our pistol fire effect. So once again, this was under the player pistol holder, under the gun script, defined this effect. So let me find it here quickly in my project and then double click to open it once again in prefab edit mode. And let's click back on the puff of smoke. To make the particles not hang around so much, we can simply shorten the start lifetime setting. But once again, to make things less uniform, we can vary the lifetime of each particle. So let's click the drop down under Start Lifetime and choose Random between 2 constants. And let's set those constants between 0.25 and 0.6. And then if we, click Restart here, we can see that play out. That's a much shorter lived effect. And once again, we can exit prefab mode and press play again to see it take effect in the game. You can see the particles exist much less in time and they're not uniform anymore. Okay, let's exit play mode. Let's take a quick look at the particle system on the pistol fire effect parent object. So once again, let's go back and find the pistol fire effect, double click on it. and we've been working on the puff of smoke, but let's look at the pistol fire effect. And if we scroll down, you can see it has its own particle system, which if we play it, you can see both particle systems here, but it's the sparks that come out. The particles in this system are 3D meshes instead of 2D sprites. So if you look at the particle system component, check out the rendering options toward the bottom. And you can see that we've got meshes selected here, both cubes and spheres. And, we randomly grab either the cube or the sphere when they come out. And the material for the mesh is set to pistol projectile material. Also notice that we have the lights option turned on. If you look at the properties of lights, it's set to spawn a point light within each particle, which makes the particles look more sparkly in the world. As you can see, particle systems give you lots of bang for the buck. If you can master creating particles, you can really enhance the visual special effects in your games. There are several other particle systems already in the FPS project. You can explore the prefabs to see how they're set up and the resulting effect to further your knowledge into creating particle systems. Let's go ahead and exit out of prefab edit mode and save our scene. In this video, we'll set up some global level management elements, such as the lighting, music, user interface, cursor control, and the game manager. To keep things organized in our hierarchy, we want a game object to store our level management objects. So let me go ahead and click the plus here and create empty. And I'm going to name this empty game object as level management. I'll also clean up my hierarchy view by closing the cascade of the FPS player, just to kind of simplify what I'm looking at. And while I'm cleaning things up, I'll also come over here and let me close up, some of our folders that we had opened here in the project window. So far, we have just been using one directional light here in the scene to light our environment. This is the default light that Unity gave us when we created our scene. You may have noticed that we get some dark shadows in our level as you walk around the level. That is because the one directional light is really more for outdoor environments where we have one strong light source, like the sun. But this level is an indoor environment. In a real-world indoor environment, there may be multiple indoor lights that effectively light the entire indoor space with little shadows. We'll simulate this effect by using multiple directional lights. So select the directional light game object in your scene, and let's just disable it. The scene will go dark, but not completely dark. This is due to the environment lighting setup under Window, Rendering, Lighting, and under the lighting window, you can see there's an environment tab, and there's an intensity multiplier here. And if I turn this up, you can see that we effectively get ambient light everywhere in our environment. Okay, but the problem with this is it doesn't really create shadows at all and looks very artificial. So let me undo that to go back to 1, and let's close this up. And if you navigate into your project folder under Prefabs, we have a lighting subfolder. And notice we have a prefab called Indoor Lighting. And let's go ahead and drag and drop this onto our level management game object, so it becomes a child of that. And you can see that our world becomes instantly lighter. And if we actually look into this indoor lighting game object, you can see it's actually made up of multiple directional lights. So you can see there's a top-down light, there's a bottom-up light, and then there's lights at various angles to basically illuminate the entire environment. And if you go into each light and look at the emissions, you can see that the intensity varies based on the light. Okay, so now we have our indoor lighting simulated here using this prefab. You may have also noticed that our mouse cursor is a bit of a distraction and gets in the way while our game plays back. In a first-person shooter game such as this, it's typical to hide our mouse cursor for in-game interactions and then show it just for menu interactions. So if we navigate into our prefabs once again and open up the utility folder, you can see we've got a prefab called Cursor Management. This prefab contains a cursor management script which manages the state of the mouse cursor. It works in conjunction with the UI manager to set the state of the mouse cursor depending on if UI menus are showing, like the pause menu, or not. And you can see the various states here. It's set to start in the FPS state, and there's also, a menu state and an SPF visible state, which would show the mouse cursor during FPS mode. Okay, so we're mostly going to use these two states. Okay, let's go ahead and drag and drop this into our level management as well. And let's just go ahead and press play to test it out. Now, since I'm in the editor, you might have to click in the game view to basically lock off your cursor. And notice now when I'm playing, my cursor doesn't move. If you actually made a build, the cursor would be, in fact, hidden. You wouldn't see the mouse pointer at all. But once again, we're in the editor, so it kind of keeps it around there. And I can click to shoot and I can still move around. I just don't see the mouse pointer. Okay, now to get my mouse pointer back here in the editor, I have to actually press the escape key, and then I get control of my mouse again, and then I can exit playback mode. So once again, in FPS mode for the cursor management, the mouse cursor starts hidden so the player can focus on the game, and the mouse cursor doesn't accidentally go outside of the game and have some mistaken clicks, for example, outside the game. Speaking of UI management, we don't yet have our in-game UI in place. Since we've set up UI on previous projects to save some time, we have a prefab already set up with the in-game UI. So let's navigate once again into prefabs within UI, and notice we have a UI manager in-game prefab. And let's go ahead and drag and drop this into our level management game object. And you can see in the game view, we instantly see some UI. And if you look at the game object, notice it's got a canvas on it and a canvas scaler and a UI manager script. And the UI manager script has various pages defined for pause screens, victory screens, losing screens, and so forth. And if we actually open up its child, you can see within it, it's got the event system, which is needed within the Unity input system. So you can use your controller or mouse, to navigate buttons and so forth. And it has various pages, so it has the pause page, the settings page, the victory page, the lose page, and then the in-game page, which is what we're actually seeing because this is activated. All the other ones are deactivated, and they're activated by the script based on the interactions of the player. So let's test it out. If we go ahead and hit play, and I'll tap just to get focus on the game view. Notice we have the reticle in the middle of the game view now. So this makes it much easier to aim at things, as well as the health display in the upper left and the lives counter in the lower left and the gun display in the lower right. Now, if we tap the escape key, it should bring up our pause menu, and notice our cursor control works. So we get our mouse pointer back so we can select buttons here. If I resume, it goes away once again. And let me hit escape again. And from here, we can click on something like settings, which will bring up our settings menu, and click back. And then we can click quit, and that will exit playback mode. Just like in previous projects, we have both a UI manager to handle UI and a game manager to manage the game states, like winning and losing and the player score. So let's navigate once again to prefabs, and under the utilities folder, we've got the game manager prefab. And let's go ahead and drag and drop that into our level management game object. And this prefab is already all set up and should be good to go. Of course, you can dive in and see how it's set up and even dive into the script if you want to look at the code. As a final touch, let's add some in-game music to our level. So let's once again navigate into our prefabs folder, and we've got a music subfolder. And you can see there's an in-game music prefab, which has an audio source component on it with a music clip defined, and it's defined to loop. And let's go ahead and drag and drop this in-game music prefab and drop it on our level management to be a child of that. Now that we have all of our level management objects in place, let's go ahead and test it out. And to do this, I'm going to go from play focused to play maximized so I get more of a full screen experience. And let me go ahead and click play. Okay, and because we're in the Unity editor, you might see your mouse pointer. If you bring up the pause and then resume, it'll get rid of the mouse pointer. And, with the addition of the music, it makes the game feel much more immersive and really heightens, sort of the feel of the game. And you can see all of our UI playing out here. Of course, we don't really have a way to get damaged per se yet, but we've got all of this UI in place, and presumably our game manager is controlling the state of things. So let me come over to the goal state. And when we get the goal state, our victory screen comes up. And of course, we don't have additional levels yet, so if we click new level, we're going to get an error down below, or even main menu we don't have set up in our build settings yet. Okay, let's go ahead and exit playback mode. Now that we've set up our level management game object, let's go ahead and make this into a prefab so we can easily add it to future levels. So let me go ahead and close the cascade here, and I'm going to put this within my utilities folder within prefabs. So let me go ahead and just drag the game object and drop it in utilities, and that will make it into a prefab. Okay, let's save our scene. Our level has some platforming challenges, but there's no real risk yet to the player. In this video, we'll add some enemies into our level to heighten the challenge for our players. Many of our enemies will be driven by artificial intelligence to navigate the level toward the player. We'll be using Unity's AI navigation system to allow our enemy to navigate our scene. In order to use this, we need to install the AI navigation system package. To do so, we can go to Window in Package Manager. And under Packages in the top left, let's go to the Unity registry. And we want to find the AI navigation package, which once again, this is alphabetical, so you can either search or just scroll through them. And here it is, AI navigation. And let's go ahead and click Install. This gives us access to all the NavMesh components that we need for this project. Once installed, you can go ahead and close the Package Manager window. Now let's add some enemies to our level to give the player more of a challenge. I'm going to close up some of my folders here just to make it easier to see things. And within Prefabs, we've got an enemies folder. So let's open that up. And you can see we have a number of enemy available to use. Let's go ahead and add the ground shooter enemy to my first room. So I might want to navigate a little bit and figure out where I'm going to put it. If you remember way back to our grid paper design, we actually had an enemy, I think, right over here. So let me go ahead and drag the ground shooter enemy and drop it, maybe right about there. So the player has to encounter it before it gets to these platforms. And with the ground shooter selected, let's look at the inspector. And if you scroll down, you can see it's got a ground enemy script attached to it. This has many of the important settings on the enemy, such as the movement speed. And you can see it can move and it's got a speed. The behavior settings, if it attacks and what range it attacks within. And the line of sight settings to determine if it needs to be within line of sight of the player before it attacks and before it moves. The enemy actually shoots a ray from itself toward the player. If the ray does not hit anything before the player, then there's a line of sight. The line of sight layer property specifies what layers to include. Right now it's set to nothing. So line of sight basically won't work now. Make sure to set the line of sight hit layer. You can either set it to everything and then it will hit basically everything in the world. Anything could obstruct it from the player. Or, we can set it just to be the player and the environment. Okay. And by setting these two options, for example, maybe we're going to have the enemy on a new layer. That would make it so if an enemy was in its way, it wouldn't obscure its line of sight, for example. Now, if I scroll down further, you can see our enemy also has a NavMesh agent component. The component allows you to create agents such as enemy that pathfinds through an environment using spatial reasoning. This is one form of artificial intelligence you see in games. In order to function properly, the NavMesh agent needs a NavMesh. A NavMesh is a mesh that Unity generates to approximate the walkable areas and obstacles within an environment. Unity can generate the NavMesh using the NavMesh surface component. So let's right click on our level management game object and select create empty to create a new game object within it. And I'm just going to name this NavMesh management and make sure that's selected. And let's click add component and we will search for nav. And notice we've got a NavMesh surface option here. Let me select this and we get our NavMesh surface component attached. This has various settings to define the type of agent and the height of the agent and things like that. And for now, we're just going to go with the defaults. So let's just click the bake button at the bottom. You should now see a blue overlay on the floor tiles, and Unity will have made a new folder and NavMesh file, likely in your scenes folder. So up here, you can see there's a level 1 folder that was created, and within that is the NavMesh asset, which defines the navigatable areas of the level. So if you look at the blue areas, you can see everything that's blue would be navigatable by our enemy. And notice that there's no blue under this platform because it's determined that this platform is too low to walk underneath it. Notice also that the area of the enemy was also defined as not navigatable. Okay, and that's because when it built the mesh, it included everything. So if I actually open up this object collection dropdown, you can see under include layers, it has everything. And this is why it's good to add layers for things. So for example, let me just say nothing and then choose the environment. So it's just going to bake the environment. So now if I bake again, notice that the area under the enemy is blue. So, any enemies could navigate over this area. So let's go ahead and try it out. Go ahead and enter playback mode. Okay, the enemy is just out of reach now, and if I move slightly closer, now I'm within line of sight, and it's going to come after me and shoot me and kill me. Okay, let's exit playback mode. So the enemy is now navigating across the NavMesh toward the player. When Unity bakes the NavMesh, it will now automatically take into account things like walls as obstacles because they're in the environment. However, you may want to add new obstacles that are not necessarily part of the environment. So it's important to learn how to make an obstacle yourself. So let's go into Prefabs once again and open environment. And within environment, notice we've got props. So let's open that and let's open up bones. And for purposes of example, let's pick this skull and let's go ahead and drag and drop it out into our world. Let me tap F to zoom to it, and we'll make it so it's positioned, kind of on the floor. And I'll place it, between the player and the enemy. So it's kind of an obstacle that we can maybe hide behind a bit. And notice if I go back to my NavMesh management and I bake again, notice that the blue NavMesh doesn't take this into account because it's not in the environment layer. With the skull object selected, let's go down into the inspector and click Add Component. And we want to add a NavMesh obstacle component. So let's do that. And let's look at it. The NavMesh obstacle component has several options. The shape allows you to choose between a box or capsule shape for the object. For this, a box makes the most sense. We could define the center and the size of the obstacle. But the most important property is carve. When this is checked, it tells your NavMesh surface to not let the AI near this obstacle. So let me check that. And you can see that my blue mesh immediately blocks off this area. We don't even have to rebake the mesh to do that. Now, when you check carve, additional settings will come up, but we don't need to worry about these for now. The defaults will work. And let me turn off play maximize to be play focused. And let's play now just to test this out. Let's move a little bit closer once again, and you can see the enemy will come toward us and it navigates around the obstacle to get to us. Okay, if you really want to test it, we can move it over a little bit more to be in a direct line between us and the enemy. Now, if we reorient our camera here, you'll notice that our NavMesh basically stops at the door. And if we look at the other side, it starts again on the other side. Okay. And what this means is that enemies will not pass through this door. We can rectify this with two modifications. Within the environment, if we find our Astro Door object, or just click on it. So the Astro Door is the entire thing, but within that, the child object is the door. So let me select that because we want the outer frame still to be not navigatable. But the door game object and its children contain the actual geometry of the door. We don't want this geometry to be included in the NavMesh, so we can tell the NavMesh to not include it. So with the door game object selected, let's go ahead and click Add Component. And once again, let's search for Nav. And then let's select NavMesh Modifier and add that component. On the NavMesh Modifier component, let's change the mode to Remove Object. So once again, we're removing the object from the NavMesh. So now if we go back to our NavMesh Management game object and we bake again, notice that the blue NavMesh goes right through the door. This partially solves the issue. However, when the door is closed, we don't want our enemy AI to walk through the door or even to walk up to it and constantly be walking into it. So we need to make the actual door slide object an obstacle like we did the skull. So if you select the door slide and the door slide A at the same time, this is the actual door that opens. We can, with both selected, click Add Component and then select the NavMesh obstacle, much like we did for the skull. And this adds it to both at the same time. And I'm just going to click Carve. And once again, you can see the blue goes away because it's carved out. And when you open the door, the obstacle moves out of the way and the enemy can pass through the open door. And with that change on the Astro Door, let me go back to it. And, I'll go ahead and apply this change to the prefab. So let me click on Overrides here. And let me close this up. And let's click Apply All to apply all the changes back to the prefab. So future doors will have that same NavMesh upgrades. Okay, our NavMesh is all set up now for level 1. There's obviously a lot more to AI navigation, but at least we have scratched the surface here. Let's go ahead and drag in other enemies into our scene, just so we have a bit more challenge. So on this side of the wall in room 2, let's go ahead and add a ground melee enemy. So I'll go back to my Prefabs enemies folder and grab a ground melee, and let's drag and drop it out here, maybe over on this side. So when we open the door, it'll come at us. If we look at this object in the inspector and go down to the ground enemy script, let's set its line of sight options the way we did the other one. So where it says line of sight layer, let's go ahead and select the environment and the player as the two options that it will shoot a ray through. And if it hits anything in the environment or the player layer, it will detect the collision. And of course, if it's the player, it has line of sight. And if it's the environment, it does not. Notice that the enemy has a health script just like the player. And it's got a different team ID than the player. The player is ID 0. So enemies will not hurt each other, but will hurt the player. And the player can hurt the enemies, but not itself. And, the actual health is set here. And if you wanted to make an enemy tougher, you can give it more health. Enemies currently are not set to use lives. It's sort of a one and done. Once they lose their health, they're dead. And they lose 1 health per shot. So you can increase the current health, for example, to be higher. So maybe this one I've got to shoot 2 times. And maybe I'll set up, the default and the maximum to be the same since I'm increasing it up. Now health and damage work together. So within the ground melee, if I open up to look at its children, notice it's got a melee swing game object on it. And this is what actually will hit the player. So here's the damage script. And this defines how much damage is done to the player. And right now it does 1 hit point of damage when the player gets hit. And we'll leave that as is. But once again, you can make an enemy tougher by providing more damage when it hits. And let's drag in one more enemy. I'll drag in the flying self-destructing enemy. And I'm going to place it, maybe above the pillar over here. And of course we can place it more precisely if we want. And this is a flying enemy, which works a little bit different. It doesn't use the NavMesh. It just, shoots a ray out in the environment. And if it hits the player, it will navigate toward it. So it's got a flying enemy script on it. And we can set it up the same way with the line of sight hit layer. And I'm going to set this to the environment and the player as well. And let's conclude by reorganizing our scene hierarchy a bit because it's getting a little messy once again. So let me collapse down everything here. And I'm going to create a new empty game object to hold my enemy. So let's create an enemy game object. And I'll select the ground shooter, the ground melee, and the flying self-destructing enemy. Drag and drop it into the enemy game object. And while we're at it, let's go ahead and create layers for our enemies as well. So with all three selected, I can go to layer and let's add a new layer. And in layer 6, I'll go ahead and create an enemy layer. And then let me go back to these. And once again, let me shift select and make sure they are set to enemy. And I'll say yes, apply it to the children as well. Okay, now the player has a bit more challenge in the level. Feel free to playtest this on your own. Obviously, you can spend more time placing enemies and adjusting their values to make an even more compelling level. For now, let's go ahead and save our scene. Let's take a quick look at some of the other prefabs provided in the asset package, which you can use to enhance this level or future levels of your game. Within the Prefabs folder, of course, we've got a variety of subfolders which we've been using, but let's look at a few things that we haven't seen yet. So within projectiles, we have 3 different projectile types. Of course, there's enemy projectiles. This is what the ground shooter enemy shoots. There's also the player projectiles, which are the various projectiles that come out of the 3 different types of guns. And then there's icicle projectiles, which are a number of icicle prefabs set up, which could be used. If you want to make more dangerous projectiles, you could duplicate and edit copies of any of these projectile types. Now, within prefabs, let's go ahead and open the environment folder once again, and let's look inside of building. When creating this first level, we've used assets from the Astro building folder here, but we also have a robot building and a cave folder that you can use in the same way. We also have hallways that you could use to connect things. All of the environment pieces our artist made are meant to be small pieces that you can snap together using vertex snapping to create more levels. We won't go through every single piece that's provided to you, but as you make more levels, I encourage you to look through all the prefabs in these folders to find things that you like. If you have an idea for a level, try building it out first in ProBuilder, then replace it with the assets from these environment folders. Don't worry if you can't find a prefab to fit your level concept. You're welcome to create parts of your level using ProBuilder shapes or Unity primitives if you want to implement a unique level and gameplay as part of your modifications and are not an artist. If you are an artist and want to create your own 3D assets, you can use the provided prefabs as reference on how to set up your own environment prefabs. A few additional environment prefabs that we have not yet looked at are checkpoints, obstacles, and jump pads. Checkpoints save the player's progress and give the player a location to respawn at upon death, as long as they have lives remaining. Let's go ahead and drag a checkpoint into our current scene next to our player's starting location so they can respawn there if they die. So let me select the first person player and tap F to jump over by. And I'll go ahead and drag out the checkpoint and place it maybe right about here. And let's make sure it's seated on the ground. Under the jump pads folder are a couple jump pads that propel the player up into the air when they walk over them. And under the obstacles folder, we have a push trap. This is a very simple object that just pushes out a piston on one side, which can push the player around. If you want to make something more dangerous, you could attach a damaging trigger to the end of it and perhaps create spikes from the ProBuilder primitive to make a more menacing spike trap from this prefab. This is just one example modification that you could make using the provided prefabs and scripts in the project. Finally, let's look at the props folder. Here you'll find a bunch of visual extras that you can use to make your levels more interesting. Let's drag in a few to decorate our scene. Let's grab a small vent and drag it out into our environment. I'll place mine along the left wall of room 1. Remember, you can change the rotation using the rotation tool or just changing it in the inspector. And all of these need to be rotated -90 to fit this wall. So I can zoom in here, and once again, you might have snapping on like me, and it may not snap perfectly, so I'll turn snapping off, grid snapping, and just pull it out, just enough so I can see the vent. Okay. Let's also drag a space logo into our scene. And maybe I'll put this on the back wall so the player sees it right away. Once again, we can tap F to zoom into it and position it. And once again, you can rotate around to kind of make sure that it's basically mounted to the wall. In our hierarchy, we could create, once again, a new game object, and we'll call this props. And we could nest our 2 props within that. And of course, we could also create one for our checkpoint. And, on a bigger level, maybe we have multiple checkpoints. So let me place that one there for now. And of course, our skull is also a prop. So let's go ahead and stick our skull into the prop folder as well. As you work on the modifications portion of the assignment, feel free to continue to explore the provided prefabs. For now, let's go ahead and save our scene. You may have noticed that we have many sounds playing now in our game, including music and various sound effects. Personally, I think the volume of some of the audio is quite loud. Further, when the music and sound effects are playing at the same time, the mixing of the sounds may not be ideal. Fortunately, Unity provides an audio mixer. In this video, we'll take a quick look at the audio mixer. Let's start by creating an audio mixer. Locate the audio folder in your project, and let's right-click on it and choose Create Audio Mixer. This creates a new audio mixer in the audio folder, and let's rename this our in-game audio mixer. You can actually have multiple audio mixers in your project, for example, for different scenes in your game. Let's right-click again on our audio folder and create a folder. And I'm going to name this Mixers, and I'll place my in-game audio mixer into that folder. Now within my window menu, let me click Window and go down to Audio and then select Audio Mixer. And this will open up the audio mixer window. If it's not yet docked, go ahead and grab the tab and you can dock it next to your ProBuilder tab. So we've got Projects, ProBuilder, and Audio Mixer all in this middle panel. And I'm going to reorient so I can see it a little bit more. On the left of the audio mixer, you can see your various mixers. Right now I've only got one. So let me go ahead and select the in-game audio mixer. And now I can see additional options, including groups. And you can see there's one master group already created, and you can see it out here. Let me go ahead and create a couple additional groups. So let me hit the plus here, and I'm going to name this as music. And then let me click back on master and click plus again to create another group at the same level. And I'm going to name this in-game SFX for sound effects. And one more time, I'll click back on master and click plus, and then I'll create a UI SFX. Okay, I've got 3 groups created, all under the master parent. Now that we have those groups created, we can go to our audio source components and set the output property to the desired group. For example, within our Projects tab, let's go to our Prefabs music folder and select in-game music. And here is the audio source component. And here's the output property, which in the past, we've never set this to anything. But let me go ahead and target our audio mixer. And we can pick which group we want it in. Since this is music, let's pick the music group. Now let's go into Prefab effects and go down to our pistol. And let's look at the pistol fire effect. And this also has an audio source component on it. This is what gets instantiated into the world when we shoot the pistol. So let's set its output to be an in-game sound effect. And for one more example, let's go ahead and look in the UI folder, and let's select the UI switch effect and go to its audio source component. And let's click on it and target the UI sound effects group within the mixer. And you can continue this process for all of the effects and really any prefab or non-prefab game object that has an audio source component on it. In interest of time, I'll just set these 3 prefabs for now. Now that we have these audio sources connected to the mixer, we can adjust their volume and overall mix within the mixer. So if you go back to the audio mixer, you can see this little indicator here, which they call the attenuation fader, and you can turn up or turn down any of these channels. But it's actually great to do this while the game plays back. So let's make sure that we're in play focused so we can see our interface. And remember, we've got our cursor manager, which takes away cursor control, and we need that to do this. So let's go ahead and select the cursor manager object under the level management game object, and let's just disable cursor management for now. And then go ahead and press play. Okay, and we might want to readjust our interface a bit so we can really see the mixer here. And you can hear the music playing, you can hear when I'm firing my pistol, and once again, over here I can adjust this, but when in playback mode, it doesn't let me adjust it unless I click this Edit in Playback Mode button. So let me select that, and now these grayed out elements come alive, and I could turn down the overall volume, the master volume here, or I could bring it back up to 0, and I could adjust maybe just the music. So let me bring that down just slightly. And if I press my shoot button, that seems pretty loud to me, so let me bring this down a little bit more. That seems better. Let me press escape. And we can hear the UI switch sound effect. And once again, maybe we'll want to adjust this down more. Maybe that's too much. Bring it back up a little bit. Okay, maybe that's better. And all of these changes, since I'm editing in playback mode, are being saved. So let's go ahead and exit playback mode. And let's go back to our hierarchy and go back to the cursor manager, and remember to turn this back on. And then let's go ahead and change play focus to play maximized, and then play again. And take note, our mix is in place. Okay, let me go ahead and exit playback mode. Like I said, you can continue to set up the output property to reference the appropriate audio mixer group on other audio source components across our other prefabs, such as those in the effects. You can even create additional groups or even additional mixers for other parts of the project. So for example, you might create an additional mixer for just the main menu. This was just a quick look at the audio mixer. There is additional functionality, and one nice thing is you can actually access the audio mixer in code to dynamically affect it at runtime. So for example, you could give the player a user interface to adjust the volume of an audio group, such as music versus sound effects, via something like the settings pop-up. In fact, that would be a nice modification to do in the second part of the assignment. For now, let's go ahead and save our scene. In this video, we'll go over how to add more levels to our game. The first thing that we need to do is add our desired scenes into our build settings. So under the File menu, let's bring up Build Settings. Currently, we just have the sample scene in the build settings. The sample scene is the scene that we automatically got when we started our project. And you may remember we experimented a bit with ProBuilder within that scene. It's very common to have test scenes in your project that you do not want to include in your build. Let's go ahead and remove the sample scene by right-clicking on it and choosing Remove. And then we want to add the scenes that we actually want in our build. And that includes the main menu scene. So let me drag and drop that into the scenes in build, and the level 1 scene. And of course, we also had the level 1 blockout, but we don't want that in our build as well. With the 2 scenes in the scenes in build list, let's go ahead and close the build settings. And let's open up our main menu scene, which we haven't looked at yet. This scene includes a placeholder main menu already created for you. It's very similar to the main menu in the previous projects. It doesn't look great, but it's functional. Now let's test our game loop to make sure everything works. Let's go ahead and enter play mode. So from the main menu, we can go ahead and click New Game, and this should load into level 1. It does, but you can see that the lighting is messed up when we loaded from the main menu into level 1. This is actually a bug in the Unity editor that would not be present in a build, but we can fix it. So let me go ahead and press Escape and exit playback mode. And let's go back to our level 1 scene, and let's go to Window, Rendering, Lighting to open the lighting window. And within the lighting window, go down to the light mapping settings and check this auto generate checkbox. Okay, and then go ahead and close your lighting window and save your scene. And let's go back to main menu again and start the process of checking our game loop. So let's click play again. Okay, let's click New Game button once again. The show should load level 1. You can see the lighting is now fixed. Let me shoot this first enemy and sort of speed run the level to make sure everything works. Grab the key card, come to the door, come through. Let's shoot our enemies here. Get up on the platform, jump over the moving platform. That'll bring us to the second pillar and get the goal. Okay, our victory screen comes up and we can click next level. Of course, we don't have a next level. So currently the next level button brings us back to the main menu. Okay, our full game loop works there. Let's also check our level select button. So I'll click on level select and we've got just a level 1 button here. If I click on that, it should bring me to level 1. Okay, I'll hit escape and then play to exit play mode. Now that we know our game works fine with 1 level, let's create a second level just to show how we would hook up additional levels. To create a new level, we could create a completely new scene and drag in our level management asset prefab that we created, drag in the FPS player, and a goal pickup, as well as build out the environment. These are the minimum things that we would need for a working level. But for sake of time, we'll just duplicate level 1. So select your level 1 scene and duplicate it. And we'll rename our duplicate as level 2. And let's double click on level 2 to load it. Let's do something simple to make it clear that this is different than our level 1. I'll add some props to differentiate the level. So within our prefabs folder, let's open up environment and props. And I'll just add some of these robot light prefabs to the far wall. So let me drag out one of them here and place it there. Let me move my camera up a little bit in the scene. And I'll just drag out maybe several of these kind of along that back wall. And if I press F, I could zoom to it just to make sure that they're basically along the wall. Looks like they are. And additionally, maybe I'll select my enemy here, which is the ground shooter enemy. And let's duplicate that just to create a second enemy in this level 2 to add a little bit additional challenge. And even though we're just creating something quickly. Let's keep it organized. So we'll take all of our robot lights and put them in the props folder. And since this level was duplicated off of level 1, if you go under Window, Rendering, Lighting, notice the Auto Generate is already checked, so we don't have to do that to fix the lighting in the editor. Okay, let's go ahead and save our level 2 scene. Now let's add this new level to our sequence of levels. Let's first go back to our level 1. And of course, when we beat this level, it brings up the victory screen, which is under Level Management and then UI Manager in game. And this has various pages. One is for victory. And of course, you can turn this on to see what it's going to look like, though you don't necessarily need to turn it on to alter it, because if I go into the cascade here, we've got the main menu button, which if you scroll down in the inspector, you can see there is a button component, and on click, there is an event that will load the main menu, which is what we want for the main menu button. But for the next level button, notice that is set to also load the main menu. And now when we complete level 1, we want to go to level 2. So let me type level 2 here. Make sure that you name it exactly the same as the name of the scene. Now our level 1 is ready to go to level 2. And let's go ahead and click back on our victory page and turn it back off so it's not showing initially. And we can close this up and go ahead and save our level 1 scene. And let's go back to our main menu now. And we also need to get the level select working here. So let me open up the UI Manager main menu, and you can see it's got the level select page. I can once again turn this on so I can kind of see the overlay here in the game view. Now, if you want to see it in the scene, currently we are in 3D mode, but if I tap F to zoom to it, you can see it there in 3D space. And if you click the 2D button up here in the scene view, it will switch to 2D mode so I can see my UI properly. And you can, within a 3D game, you could constantly switch between 2D and 3D rendering here in the scene view. Okay, so you can see our level select. If I open up the level select page, you can see there's level buttons. Let me open that up, and here's our level 1 button, which just like the next level button, if we scroll down, it's got a button component on it, and an on-click event, it loads level 1. So we'll use the level 1 button as a template for our level 2. So let me select the game object and hit Control D on Windows, or it's Command D on the Mac. This made a new button. And since this is in a vertical layout group within the level button parent object, it auto lays it out for us. So let's go back to it and rename it as our level 2 button. And within the button component, we want to change the action on click. Rather than loading level 1, we want to load level 2. And then we need to change the label of the button. So once again, that is a child object of this game object. So here's the text child object, and it's a Text Mesh Pro text component here. And we'll change the text from level 1 to level 2. And now our button is set up. So let's go ahead and disable the level select page. And we'll close everything up here and save our main menu scene. Now we just need to remember to add our new level to our build settings. So once again, under the file menu, we could bring up our build settings, and we've got the main menu and level 1, but we don't yet have level 2. So let's drag level 2 into the build settings. This is a common mistake. People forget to add their levels to the build settings. So try to remember that. And of course, always test to make sure things work. So let's close up our build settings and test everything. So I'll go ahead and press play here. And we'll start by clicking New Game just to make sure our full game loop works. So I'm on level 1 here, as you can see, and I'll beat it once again. We made this purposely easy to beat, just so we can get through it quicker. I'll get up on the moving platform. And I get to the victory. Now when I click next level, hopefully it loads to level 2. And I'm on level 2. You can see the robots over there. You can see the 2 enemies. And I'll quickly beat this as well. Maybe. We'll jump on the platform. Move over a little bit and then jump across and go to victory. And if we hit next level button, we don't have a next level yet, but it should be set to go back to the main menu. And then once again, let's check our level select. So let me click on level select. We've got our level 1 and level 2 button. If I click level 2, it should load right into level 2. And it does. So let's go ahead and hit escape and exit play mode. Okay, we have a fully functional 2-level tutorial game now, complete with a main menu. In this video, we'll take a look at the player controller script so we can get a deeper understanding of its inner workings, learn a bit more C# coding, and talk about the coding standards used across the project scripts. Back in Unity, let's right-click anywhere in the project panel and select Open C# Project. This will open Visual Studio. If you don't see the Solution Explorer, select View Solution Explorer on Windows, or if you're on the Mac, select View Solution. It should appear either on the right or left of the window. Once you have the Solution Explorer opened, go ahead and open the cascades to go down into Assets, into Scripts, and into Player. And I'm going to go ahead and double click on the player controller to open it here in the editor. If you get this inconsistent line ending statement, this is just because we've taken the scripts back and forth from Mac and Windows. You could just ignore this. I could just always show dialog. I could uncheck that so it doesn't show, and I could just say yes here. We've talked before about the using statements, the class definition and function definitions, as well as variables. So we won't go into too much detail about everything in this script, but we will talk about the process of making these scripts and the coding standard we used in this project. So what is a coding standard? A coding standard is an agreed upon structure of how to write code. You can have different coding standards across different projects, teams, and companies. But the point of having one is to make the code more readable and easy to understand by having the same rules followed by everyone on the team for every script in the project. In this project, all the provided scripts were written using the same coding standard. One of the rules we followed in this coding standard was to have class headers, like this one, at the top of each script. This is a summary block comment that provides additional description about what a class does so that anyone new to the script would have an easier time understanding what the script does beyond just the class name. Another rule that we had was to put tooltips above every public variable in this class. This makes the code more readable, and it helps you understand what the component variables or properties are in the Unity editor, because they pop up as tooltips, without having to jump into the code. I like to say it makes your code more designer-friendly. For non-public variables, like this one here, since they're not shown in the editor and hence have no tooltips, comments should be provided just above the variable to describe what the variable does if it's not clear. The reason for this is the same as the class header, to make the scripts more approachable to those new to the script. Another important rule we followed was to have distinct casing used between our classes and functions versus our variable names. So our classes and functions have every first letter in a word capitalized, which is called upper camel casing. Whereas the variables use lower camel casing, where the first word is lowercase and then the first letter of every word past that is uppercase. This provides a visual distinction between the two, so if you're reading the code, you know if you're looking at a variable or a class or function name immediately just by the casing. We also chose to have variable, function, and class names be more descriptive instead of using abbreviations. A variable named Player health conveys what it is much more than something like pH. Therefore, the code is much more human readable and understandable. Another rule we followed was to have headers for any distinctive grouping of variables, like this, so that the variables would be labeled in the inspector. Once again, this makes the script more designer-friendly. It also means we group related variables together in our code, which is another rule in our coding standard. There are two lines of thought with organizing class variables within your script. Some people like to put them all at the top of the class before any functions. Other people like to put variables near where they are used in the code. This is called the principle of proximity. We decided to use the latter in our coding for this project. You can see this if you scroll down to the process movement function. The move direction variable is defined right above the function in which it's used. For variables that are used across multiple functions, we kept those at the top, though. Another rule we followed to make the code easier to understand is to have a function header above every function that describes what the function is meant to do, what inputs it takes, and what it returns, if anything. With more complex blocks of code, we often include comments to explain the logic of the code right within the function. These rules I've mentioned are some of the bigger points of the coding standard we used for making the scripts for this project. There are a lot of best practices to follow when writing scripts, and having a coding standard for a project encompasses those best practices and provides programmers with a guideline to follow which will make their code better. A coding standard also gives a point of reference for programmers when they do code reviews. Part of the process of writing code is to have someone else, or yourself if no one else is available, review your code. A coding standard helps the reviewer point out areas that need to be improved. In the future, if you work on a team, or even on your own writing code, you should do code reviews to make sure your code is understandable and well written, just like you would proofread a paper in an English class. Something like the player controller script is a relatively complex script, representing over 200 lines of code. But you should be able to leverage the coding standard and practices that we've used to hopefully understand what the code does, and as your experience in C# code increases, how the code works. Do your own code review now and see what you can understand. Learning to reverse engineer someone else's code is an important skill in learning to program. The coding standard should help you in this process. In this video, we'll take a look at the health script to discuss ad hoc programming compared to generalized code. In the solutions panel over here, open the health and damage folder and double-click the health script to open it here in Visual Studio. The health script handles the health state of the game object it is attached to, including health points and lives. It follows the same coding standard we just discussed, so the code should be fairly easy to read as you walk through it. The health script, as well as the damage script that works with it, are good examples of code that generalizes across many use cases. That is, we need health on the player, the enemies, and the environment, as well as across many projects. In fact, we've reused the same or slightly edited versions of this health script in all the games that we've created. So having a general health script to cover these very similar use cases makes sense. But we could have just as easily made a player health script, a enemy health script, and so on, with a lot of repeated code that effectively does the same thing. So with this example, having a general health script written in a robust manner to cover all the use cases made sense. We write it once and use it many times. It becomes a script that we have in our library of tools that we can pull out on future projects where we need health. It allows us to leverage our previous work to create games smarter and faster. This is in contrast to ad hoc programming. Ad hoc in Latin means for this. So ad hoc programming is writing code for a specific purpose rather than a generalized purpose. If we click back on the Player Controller tab, this script is a good example of ad hoc programming. You might be able to imagine a generic controller class that handles controllers for 2D platformers, first-person shooters, and 3D platformers, but that sort of generic script would be needlessly complex if you're working on a project that only needs one of those. Hence, this script only does what it needs to do for controlling a first-person character, and that conciseness makes it both easier to create and easier to understand. The point of this discussion is to show that both ad hoc approaches and generalized approaches have benefits and drawbacks. When you start writing new code, you should take a second to consider whether it is more beneficial to write your code specifically to one use case or to generalize the code to work with several use cases. And the answer, of course, will always vary by the project you're working on and its circumstances. Learning to program is a process that takes time and effort. Overall, we hope each project that we've done has slowly added to your knowledge and understanding of programming techniques and best practices. As you embark on the modifications portion of the assignment, feel free to explore the other scripts in this project to further your knowledge. In this video, I'll discuss finishing up your first-person shooter project. Your objectives will be to back up the tutorial project, expand and modify the project to make it your own, gather screenshots, create the final builds, compress the builds for distribution, publish the game to the internet, and provide the URL to the location of your game for assessment. The most important thing in the final step is to follow the instructions of the assignment in terms of the required modifications, what builds you should include, how to compress your builds, how to publish the project to the internet, and how to turn it in. Please reread the assignment while you go through these steps. As I've said before, I encourage you to strive to create something awesome, something that you're proud of, something that you want to show off to your friends and family. In fact, you should get as many people as you can to play your game during development to help you improve the game, and once you are done, to celebrate what you've created. In any case, best of luck in finishing up your project.